kind of thing. Please let me know. Am I audible, right?
Yes.
Yeah, we are familiar with those, but still
Okay, you
need
can
that.
unmute yourself if you have. If you want to say something, you can unmute yourself and then you can say.
We are familiar with. I'm familiar with
Okay, learn
those
but
topics. But
long back
please,
and to
yeah,
refresh.
long
Okay.
back. Yeah, yeah.
Okay, so most probably you will have 2 to 3 sessions mathematics, and in this session basically we will cover some functions, relations, and a quadratic equation, some straight line concept, like some sort of geometry kind of thing. Especially in that we will cover angle between two lines, equation of lines,
फोटो खींच रही हो
and then we'll start yes, it triangle area of triangle kind of thing. Then we'll start quadratic equation, then we will go towards polynomial things. I am familiar with quadratic equation, but functions and relation is new for me. Okay. Okay, let me know how many of you are, please, if you are not from mathematics background, please write Y in chat box so that I will be aware about it. So that this class will go like that only. At least I have to think from where I have to start. Please write Y if you are not from math background in chat box. Your exam is on 24th, right?
It's on 28th.
28th.
Hello?
it's
Okay,
on
just
28
a minute. I think my headset is not connected, so I'm not getting anyone's voice.
कर दिए
And I was thinking that no one is speaking. Anyone please unmute yourself and then let me know whether the voice is coming.
Yeah, it's on 28th.
Yes, sir, it's audible.
Yes, okay. So your exam is on 28th. Okay, fine. Fine, now it's audible. Okay, anyone, if you guys are not from mathematics background, please let me know, okay? Please write Y in chat box. I'm just waiting for 2 to 3 minutes. Okay, so can I assume that everyone have at least some basic idea about a functions, relations kind of thing, or quadratic equations kind of thing, polynomial kind of thing? Okay.
Yes.
Kumar, you are not from mathematics background?
I am from mathematics background. You can assume that we have an idea of functions and mathematics.
Okay.
I think couple of people like Saloni and Dennis are not from mathematics background.
Okay, fine.
No, sir, I am from mathematics background, but functions and relations are new for me because I am from BCom background, Bachelor's of Commerce background.
Okay. So you haven't learned this kind of thing in your +2, right?
No, sir, not even in +2 and also not even in bachelor's.
Okay. No issue. I will take care of this.
Thank you.
Okay, so basically what I will do in this class, I will explain some concepts of functions, relations, what kind of relation it is, and some sort of relations, and then I'll move towards straight line kind of thing. So in the straight line concept, there are some few things like equation of lines and Cartesian plane, that kind of thing is there. They're just formula based things are there. So we will just touch those things, and then we will move towards quadratic equation. We will see what are the quadratic equation, what are the its roots and zeros of what is quadratic function and all, and then we will move towards polynomial function. That's it. This is the today's agenda. Okay. I'm just finding my notes so that I will start. People to find where I apart from this, how is going your preparation? Preparation for your end sem or for your qualifier exam, what you say?
Okay, okay, sir.
Okay. Not so good, not so bad.
Yeah.
You used to watch videos like which
So you have the content, right?
yeah, I have gone through that one, but sometimes, right, like it's hard to focus. Like sometimes, like some doubts, you don't know how to answer.
Okay. Also, one more thing that I want to. So, if you have some specific doubts on some specific concept, then please stop me there and then let me know so that I will be able to clear all those things. Okay.
Okay, sir.
Okay.
Yes, sir.
Okay. So just stop me. It's okay. It's not take much time, so that I will be aware how from where you are lacking. Any general question? If you have any general kind of question, or if you have some concern about this course, you can ask me by now.
Sir, can we carry some paper or pen with us to just do the summation in something?
Now,
Now, no, on the day of exam.
no, I guess they will provide some notepad kind of thing so that you can
Ah,
do
okay.
your rough work on this.
Ah,
They
okay.
will provide. Okay.
Sir,
Yes.
sir, are we allowed a scientific calculator with us?
There will be scientific calculator, just like have you seen the GATE examination kind of thing, JEE advanced examination kind of thing? So there will be
Yeah.
some calculator kind of thing in the
Okay.
right corner or in sorry.
So they'll provide us. We don't have to bring one.
Yeah. There will be like in your basically
On
in
the
your
screen.
computer screen, or there will be some GATE calculator kind of thing. You can practice on those calculator. There is a nice app on what to say, Play Store or App Store. I don't know, but yeah, Play Store. There is a one nice app known as GATE calculator. You can download it from there. There will be, you can find the scientific calculator, and you can practice on this calculator so that.
And sir, I wanted to know, is there negative marking in the exam?
No,
Okay.
no negative marking is there. So you want to attempt all the question, right? If you are not able to solve the question, just put just do the guesswork on.
And sir,
That's
just
the nice
like
thing. If you don't have negative marking, so you can directly start this kind of thing. You can directly do this kind of thing. If you are lucky, then your answer will be correct. A nice strategy, basically.
And sir, I wanted to know particularly like the questions that we had in the videos that were given to us to prepare for the exam. There were really a lot of multiple choice questions having multiple answers, like in JEE Advanced. So it's gonna be like that, or like we're
Yeah,
gonna
yeah.
have
There will be
questions
some
like JEE Mains only, where only
yeah.
one option is
No.
right.
The thing is, this is why That is why we are not putting negative marking there, no? Because there are some multiple choice question kind of thing. There are some numerical answer type question kind of thing,
Okay.
and there are like one correct option that kind of thing. This multiple, like, yeah, a variety of questions are there. It's not like you get only objective kind of question. No,
Okay.
it's not that.
Thanks.
You will get various kind of questions. Okay. Okay, so
Sir,
I'm not able to find my notes, so I will start by PDF only.
Oh, one more question, Arpit.
Where I put the okay.
Arpit, one question.
Yes.
So, how many marks does maths hold? Do you know?
I guess 50, right?
50. That's
Have you seen the previous
yes,
year
sir.
question?
Yeah, the model paper says that it holds 55 marks.
Yeah, that's true.
Oh, so whatever in the model paper, that's right.
Yeah.
Okay.
Mock test starts are also there, right?
Yeah.
So you can see.
Okay, sure.
And weightage, like question will be like this only. Like what are the patterns of the question? I am not saying the exact question will be there, but yeah, pattern of the question will be like that only.
Understood.
Okay, there will be no such type. It's not like we have given to you some sort of pattern. It's not like we have given answer like question from numerical answer type, and we are asking for objective based question. It's not like that. Okay.
Hello, sir. What about diploma in programming? How many marks will maths hold in that case?
I think same, no, most probably same thing is there.
Okay.
50 or 55. I don't know exactly, but yeah, I will let you know in the next session. Okay.
Okay. Thank you.
Because this is that qualifier, I don't have that much idea about it. So, I will.
Sir, I have a question.
Yes.
Sir, in today's session, we will do some practical questions or it will be only theory?
It ups to you now. If you want me to solve some practical question, I will solve that question because we have only 2 hours, 2.5 hours. Barely I can extend it by 3 hours. Though I have taken a session for 5 hours, but yeah, there is time bound for everyone, right? So in that time of period, whatever I can solve, I will solve. Okay, whatever I can do, because some
Yeah,
of you guys are not from
just one
mathematics
practical
department.
questions.
Sorry.
So yes, sir. So like first, for example, give us one practical question so that it will be clarified. Like
Okay.
Easier
concepts
for
will
us.
be clear, easy for us.
Okay. So if you are not able to understand the concept, how will you solve that? Like, how will you understand what is going on there? This is the
We would
main
ask.
thing, no? Uh-huh.
We would ask on that step.
Okay. So, okay. That is also fine.
Right now,
So,
the
do you
method.
have some questions?
Yeah, I mean, model papers are there, right?
Yes. So, we can solve that model paper as well. It's
Yeah.
up to you. It's not my choice. It's your choice. Whatever you want me to explain, I will explain, or I will explain the concept as well. It's up to you. Just let me know what I have to do so that it's basically, if it is clear in the beginning of the class, it is very useful for us. And
Sir, are these model papers available on the website?
most probably yes.
So please, anyone can share model papers link.
Yes, please share the model paper so that where you will share. Just paste the link if you have, so that I will open and then share the screen, and we'll start solving like that. Okay. Okay. I got it. This is mock test. So you want me to solve this, right?
Yeah.
Okay, no issue. Okay, let's see the first question. Okay, one more thing before starting this, I want to ask those who have said yes, they have some bit idea about, like they don't have some idea about the relation and function. Do you want me to explain those kind of thing?
Yes, sir. Please, sir. Relation and functions is
Yes, sir.
important.
Okay, so
It will.
firstly, what I will do, I will just, I'll just give you the idea. Like not everything I will cover. I will just give the idea about function and relation, and then we'll start solving this question paper.
Yes,
Is
sir.
it
Yes,
fine?
sir. Yes, sir.
Okay, what are the things are there in this question paper? Let me see first. This is for math one on mathematics for data science one. Okay. This is a graph theory portion. So I will not take this graph theory portion because when the graph theory part will cover that person or if I will cover those kind of concept. So I will take this question. Okay. And this is also, this is set question. Okay, fine. Here most of the questions, okay, this is for our interest. Like only 2 to 3 questions are here only for our interest.
I mean, this is the paper for all the total syllabus, right?
Yeah, this is for our interest. There are few questions only. Okay, no issue. Okay, I have some practice assignment kind of thing. I will try to solve the question from there itself. Okay, before doing this kind of thing, let's start with relation kind of thing. Okay. Okay, so what is relation basically? Anyone have any idea about it? Relation. Okay, before starting the relation, there is one thing that you have to know about set. What is set? Anyone? What is set basically?
Group of elements, entities.
Sorry?
A group of elements or entities.
Okay, so someone is saying the
Sir, it's a well-defined collection of objects and things
yes, the
set
group
therein.
of elements. Okay, so one more thing is coming into the picture. This word, what do you mean by this element? Here, this 2 to 3 words. And someone is also saying a well-defined collection of object. Defined collection of object. Okay. What do we mean by this well-defined word here? If we are defining something, and in the definition also we are saying it's a well-defined collection. So
It
it's
is
not
relation
Means it's a
between.
particular set or particular thing that contains something.
okay. Okay, let's start with this one. Okay, so basically, suppose this is me. Okay, I am a nice person, looking like a Ravan kind of thing. Okay, so this is me, and I went to the shop. Okay, which kind of shop it is? Medical shop. Okay, medical shop. And I told to the shop owner that I want paracetamol. Okay, this is the basic example that I have given in the each and every class. So I went to the medical shop and I told to the shop owner that I want to this paracetamol medicine. So if you will closely observe to this person, this shop owner or chemist, whatever you say. So if you will closely observe to this chemist, okay, this chemist will go to some place, like there are some places this kind of thing are there. Okay, this is drawer kind of thing. Okay, this kind of things are there inside the medical shop. So here will be some boxes, there will be some boxes, there will be some boxes, there will be some boxes. So what he will do, he will go to some special place and he will choose some special box and he will took the medicine from that box and he will give it to me. Right? This kind of thing happens. Right?
Exactly.
Right? So what he have done before, if he is there, so how he know, how this person know that this box containing some paracetamol medicine. So initially something was he purchased some sort of medicines and he collected all the paracetamol medicines, okay, all the paracetamol medicine, and he took all the medicine into this box, right? Then only he can know, he will know that this particular box will is containing paracetamol medicine, and he put a sticker on that particular box, right? Right, so that particular box will represent the collection of paracetamol medicine, right?
Yes, sir.
Right, that thing is happened before I went to the medical shop. So why he has done this kind of thing? Why he has done this kind of thing? There
Makes his job easy.
Either he will not do this kind of thing and he will just go and find where is paracetamol, where is paracetamol, where is paracetamol, and after 1.5 hour he will take the paracetamol. Somehow he will find the paracetamol medicine from the bunch of medicine and then he will give it to me. Or he has another option that he will collect all the medicine in the beginning and he will arrange according to their names and he will directly go to the shop, like go to that particular box and took the medicine and give it to me. There is two options. So why he has choose the second option?
To reduce the search time.
Exactly, to reduce the search of time. So whenever someone will come to him and then ask for some medicine, he will just directly go to that chamber and then take the medicine and give it to that person, right? So my objective is what? Reducing the time, right? Reducing the time, or for my convenient as well, right? Similarly, in the mathematics, what thing happens? In the mathematics, what we will do, we have a bunch of numbers, we have a bunch of several type of things, okay? So according to their properties, see, since in the bunch of medicines there will be some certain kind of property that each medicine will specifically follow, right? Like paracetamol medicine, you will say, yeah, this paracetamol medicine for 600 mg, this is for 500 mg, this is for 250 mg, that kind of thing, right? There will be some certain property for that some sort of medicine will follow. Just like in this case also, there is a certain property for that particular numbers or that particular collection kind of thing will follow, right? There will be some certain property. So according to that property, if I will collect all those things, and whenever I will use, like whenever I have to define something from that particular thing, suppose I need 1 as my input. So what I will do, I will directly go to the natural number and then I will say, just give it to me 1. So I will take 1 from there and I will define something. I will take it as input, right? Right? Suppose I need 2000. So what I will do? I will go to the natural number and I will say, just give it to me 2000, and then I will use according to my need.
Yes, sir.
Got the idea why I need this collection?
Yes, sir.
Yes, sir. Yes, sir.
Right? Now, another thing is come. What is this well-defined means? Okay, suppose I am asking to you, just give me your favorite cricket player. Okay, Indian cricket player. Just give it to me the name. So I am representing as suppose A1. Some A1 person is saying me, okay, someone please unmute themselves and then let me know their favorite cricketer. Two only, okay?
Rohit Sharma.
Rohit Sharma
Virat
and
Kohli.
Sir, Virat Kohli.
Okay. Okay, another one.
Maxwell.
MS Dhoni. Sir, MS Dhoni.
MS Dhoni, and I am not asking for abroad, okay? I am just asking for Indian cricket team.
Sir, Ryan Parag.
Ryan Parag. Okay. Another person.
Chahal.
Okay, Yuzvendra Chahal.
Sanju
Okay.
Samson.
And Sanju Samson. Okay. So what you have seen? Question was same, right? I am just asking for your two favorite player in Indian cricket team, right? But for this A1, this is Rohit Sharma and Virat Kohli. For this person A2, this is Mahendra Singh Dhoni and Riyan Parag. For this A3, this is Yuzvendra Chahal and Sanju Samson. Does this kind of thing happens in the chemist shop? Like for the shop owner, this medicine is paracetamol, and for me this is something else, Cerodon kind of thing. Is this kind of thing happens in the medical shop?
No, sir.
No, it means that there are some certain kind of thing are there that right now we don't know about it, right? So what kind of thing is there? We need collection that I know. Okay, just a minute. Okay, we need collection that I know, but every collection I cannot do anything, right? Like this kind of collection, this is also an collection, this is also an collection, this is also an collection. But the thing is that my question was saying I want to know the favorite player, right? Two favorite player, but for each person, this collection is changing, right? The member of this collection is changing for everyone, like person by person.
Yes,
right?
Yes,
Person
sir.
by person, this collection is changing. It means that I need to define some rules for that. This collection will be same for each and everyone, right? I need to decide.
Yes, sir.
What is my observation? I need to define some rule so that this collection will be same for everyone, right?
Yes, sir.
For everyone. So for this kind of thing, this well-defined word comes into the picture. Okay, so here this well-defined means the collection should be same for each and every person. Okay, if I will ask the person who is living in the Chennai or who is living in the Europe, Russia, wherever he is live, doesn't matter. If we will ask to that particular person, he has to know about that particular collection should be unique. Okay, that particular collection should be same for each and every person. If someone is in Mars and I will ask to them, just let me know what is the collection of natural number. He will say, yeah, 0, 1, 2, 3, 4, 5 kind of thing, right? If I will ask what is the real number, collection of real number, he will say set of all the numbers who are sitting in the real line, right? That should be unique, right? If I will ask to them, just let me know the collection of English alphabet, he will say A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P kind of thing, right? This collection should be unique for each and everyone, right? Again, if I will ask, just let me know all the captains of Indian cricket teams, that collection should be unique, right? Up to this particular time, that collection should be same, right? If I will ask some like if someone is living in the moon, so if I will ask to that person, he will also say the same collection, right?
Yes,
sir.
Right? So you understand why we need this well-defined collection. So understood this definition, a well-defined collection of object, why we are seeing this kind of thing. We need collection. Why we need collection? Because whenever I will need something, so from that particular thing, I will directly collect those kind of thing from that collection, and I will do whatever I will use that particular thing as my need, right? And why we need this well-definedness? Because whenever I am talking about this collection, so for same question, what I am seeing that this collection is not same for each and every person. It is changing from sometimes it is changing according to the person, right?
Yes, sir.
Right? Now
Yes.
Yes, sir.
Since in the medical shop, whenever firstly what he have done, he have separate all the medicine and then he put all the medicine into the separate box and he labeled that particular box, right? Suppose this medicine is belongs to paracetamol medicine, so each box he has labeled, right? So similarly in the set also we will labeled some particular collection, like so how we will label? So basically for denoting this particular set we will use what? Capital letters of English alphabet. Okay, and for denoting the member of the collection we will use small letters. Okay, this is general examination. Okay, now this is just a definition. I just want to know, I just want to let you know this kind of definition because it has to be clear to you, though this will not come into your exam, but still just for information I have given this definition. Okay, apart from this, so everyone knows what is cardinality of a set? Number of element, right? Cardinal, if S is set, so what is cardinality of S? What is it?
Number of
Someone will say
elements.
this, someone will say this. Different notation are there. So basically this is what? Number of members or number of element in set S. Okay, understood? Understood up to this? And one more thing is there, this intersection property. Everyone knows about this, or shall I have to explain this also? Same similar thing. Just go to the medical shop. There is a there is a possibility that there are some special type of medicine which will be useful for headache and as well as fever, right? Right? There is a
Yes, sir.
possibility that there will be
Yes,
some
sir.
medicine which will be useful for headache and fever as well. So what he will do, if he will arranging the medicine according to their property, then he will took this medicine. He can took this medicine in the headache box and fever box as well, right? Both, wherever he wants.
Yes, sir.
Similar thing is there. This intersection is what? This intersection, it means if I am collecting this intersection, it means we will collect all those X such that this X should belongs to A and it is inside B as well. Okay. So we are collecting all those elements such that that element should be inside A and B as well. Okay. Similarly, A union B, it means what? If the X is inside one of the like if X is inside A or X is inside B, doesn't matter. So we will collect all those elements like A and B, both elements we will collect. So it means what? Either X belongs to A or X belongs to B. Okay, this is what. And subset kind of thing is there. So subset is what? Suppose you have a set A. So any subcollection is mean for if we will take some element, any cardinality element, like some element, suppose I have choose to 4 element from there. So that collection, see, all the elements are coming from this set as only, right? If A is my set, so what does it mean by subcollection? So all the elements what I am taking, if I am taking any elements from this set A, so that collection of elements is known as subcollection. Okay, or we will say it's a subset of A. So what is the definition of subset? So any set B is said to be subset. This is the sign of subset. Subset of A if and only if X belongs to B. This implies X belongs to A. Okay, for all X belongs to B. This is what belongs to sign. Have you aware of this? Belongs to means that X is inside B. X is a member of B. X is an element of B. This is what? For all. For all means it is talking about all the members of B. Okay, this is implies everyone knows about it, and this is subset sign. Okay, so any set B is said to be subset of A if all the members of B is also a members of A. Okay. Okay.
Yes, sir.
Are you getting my point?
Yes, sir.
If you will have any doubt, please ask. Okay. And then what you have some formula of this one. This is very useful formula. Sometimes some question will come from this formula as well. Okay, so cardinality of A union B is equal to cardinality of A plus cardinality of B minus cardinality of A intersection B. And similarly, cardinality of A union B union C is what? Cardinality of A plus cardinality of B plus cardinality of C minus cardinality of A intersection B minus cardinality of B intersection C minus cardinality of A intersection C plus cardinality of A intersection B intersection C. Okay, this is two formula. Now we will move towards relation. Okay, what is the dictionary meaning of relation?
Connectivity between two sets or objects.
Okay, in a real life, if we will ask for real life, what does it mean?
Like Facebook friends or Instagram.
Facebook friends, okay. Like your mom, dad, right? What is the relation between you and your mom? Mother-son relation, right?
Yes, sir. Mother-daughter
So-
relation, mother-son.
Yes. So basically, what we are doing with this relation, we are connecting to people from different set or same set, right? Or set, just you can imagine set is as your family. Okay. So what we are doing with the help of relation in the real life, with the help of relation, we are connecting the pupils. We are connecting the elements of family, or we are connecting the elements of set, right? Right? Say something.
Yes, sir.
How's the juice?
Hi, sir.
Okay. So before starting this relation, let's define Cartesian product. Okay. Cartesian product. So let A and B are non-empty set. Non-empty set, it means non-empty set means
Null set.
null set. Yeah, this is the notation known as phi. It is not exactly phi, but sometimes we will say it as phi. Okay, this is not phi, but we will say it phi. So we will not use this phi. We will say just empty set or null set. Okay. So we will use this notation known as null set. And null set, it means what? There is no such member inside this. The cardinality of that particular set, this phi, is 0. It means that it's nothing is there. Okay. Sometimes if we are not doing some anything, it means that we are doing something. In Hindi, what we will say, कुछ ना करना भी कुछ करना होता है, just kind of thing. Okay.
Yes, sir. Yes,
Okay.
sir.
So if A and B both are non-empty set, then the Cartesian product. This is the definition. Cartesian product. Denoted by A cross B. This is a Cartesian product, A cross B, and defined as follows. And what is the definition of A cross B? A cross B equal to, we will collect pairs. x and y such that all the pairs here x, the first element is coming from A and the second element is coming from B. Okay, so what we have done here, we have choose one element, we have take one element and me okay, for example, let's say A is my what to say, A, B, and B is my 1 2 3. Then what will be my A cross B? What will be my A cross B? So what is the definition? The definition is saying we are taking all the possible pairs from A and B, where first member will come from A and the second member will come from B. Okay, so what are the possible pairs that I will get?
A1.
Okay.
A1.
Okay, so I will choose this A and then I will meet with each and every member. Okay, so it's not like suppose basically in Indian marriage, what will happen? Once if like suppose this is what to say, boy side and this is girl side. Okay, by boy side and this is girl side. And suppose boy in the family of boys there are four members or two members, mother and father, and this boy itself. Okay, and in the girl side there is mother, father. Okay, suppose M1 F1 and B1, M1 F1, and this is brother and the girl itself. Okay, G1. So this is B and his brother in his father is M2 M2. Otherwise they will become brother and sister. Okay, and this girl G. So when they will get married, what will happen? This boy, if they have fixed a meeting with the family itself, so what will happen? So have you seen or not? Firstly, the oldest member who will be the president of this particular family, right? So this father will be most probably father will be the president or father will be the mukhia kind of thing. So what he will do? He will go to this family and he will meet with each and every person. He will meet to his father, then mother, then brother, then his sister, her sister, and then that girl itself. Okay. After meeting, after finishing this meet, this mother will go and do same kind of thing, right? So he will go to the father and he will say, hello sir, I am this, my son is doing this, my daughter is doing this, my son is that much eligible for your girl. That kind of thing is happen. So what is the basic thing that you have to remember? You have to remember that whenever we will define some relation, like whenever we will go for any relation in the real life case, so what will happen? Father will go to introduce yourself to each and every member separately, right? Each and every member to each and every member to this set, right? Or who will be the oldest person of this family? He will introduce each and every member of this family to this family, right? Right? Similar
Yes.
thing is happening here. Similar thing is happening here. In Cartesian product, what we are doing? We are doing a marriage between this A and B. So now this is father. So what he will do? He will firstly introduce himself. This is me to this one. Then he will introduce himself to this two. He will introduce himself to this three. Now his job is done. Now B is come to the picture, and then he will introduce himself. This kind of thing happen. So now we took all the possible pairs, right? We took all the possible pairs. These are the possible pairs where in first place only A member will sit and second place only B member will sit, right? So this kind of product, this kind of set is known as Cartesian product of A and B. Here order will be matters always. Okay, order will be matters always.
Yes, sir.
So remember those kind of thing. Okay, understood up to this? What is Cartesian product? Set we have understood, cardinality of a set, some formula we have seen, intersection, union, subset, and this Cartesian product. Up to this, any doubt?
No, sir.
Though I am going very fast, but still that's what we can do. You know. Understood up to
No,
this?
sir. Everything is clear.
Everything is clear? Okay, fine. Now let's move to the relation. So relation is what? Basically, we have seen here. This is what we are relating something to something, right? Right. So suppose that here are this boy. This boy is very dust in this family. Okay, he is very dust in this family. So this person, what he will do? His father, the mukhya of this family, what he will do? He will not going to introduce this person, right? He will say leave him. He will say to this, take this 1,000 rupees and do whatever you want. Just go, go away from my house. That kind of thing he will do, right? In the initial state, that's what I am saying. He don't want to introduce this person, right? Because he is very naughty kind of person. He is very dush kind of person, right? Because this for this person, the image of this family will reduce, right? So the father will not want to introduce this this person to this family, right? Right?
Yes, sir.
But there is a possibility that there are many people are like this. So what he want in the first impression, he want to introduce their best thing, right? Right? So suppose he wants to exclude this person and this person, and similarly he want to exclude this person and this person. And what will be my next set? Suppose R, what will be here also? If this person will not want to introduce this B, and here this not want to introduce this 2, so what will be my set R from this? A will meet to 1. Now he is not going to introduce this 2, then he will meet to 3. Similarly, B is not there. So this will be the set, right? The next set will be this only. But here
Yes,
also
sir.
we are relating. Here also we are relating with A and B. Right?
Yes, sir.
Yes, sir.
And observe that this is what? This is a subset of A cross B, right? Because all the members of this are also the members of this. See, A1 is there, A1 is there, A3 is there, A3 is there, right? Right?
Yes.
So this
Yes,
kind
sir.
of thing is known as relation. So what is relation? Relation is basically any subset of A cross B, no matter, it will be empty as well. Okay. How it will be empty? In this example as well. Suppose this person go to this father and they will fight each other. Now he will go to his home. He will go to his home. There will be no such marriage kind of thing happen. So the relation will be empty in this case, right? Right?
Yes, sir.
Okay. So empty is also possibility. So any subset of A cross B is said to be relation between between A and B. Understood? Here what it means, A is related with 1, A is related with 3. Understood up to this? Any doubt?
No, sir.
No, sir.
Okay. Now there is a possibility that I am defining some relation. Here I have defined from A to B. It's up to my mood, right? I can define from A to A itself. Here we were doing marriage. Here I can do anything apart from the marriage. Like I will define mother and son relation as well, right? So for that, this B will be equal to A only, right? So what will be the A cross A? If your A is AB, so what will be your A cross A in this case? A will meet to itself.
AB,
yes, then
BB and BA.
BB and BA, right? This kind of thing also possible, right? Right?
Yes, sir.
Okay, one more thing you can observe here. If cardinality of this set A is 2 and cardinality of this set B is 3, then what is the cardinality of A cross B? 6, right?
6.
2 cross 3.
6, sir.
Yes, sir. 6.
Similarly, if I will say cardinality of A is my n and cardinality of B is my m, what about the cardinality of A cross B?
M into N.
M into n. Why it is m into n? Just like here, this person A, how many possibilities are there? 1, 2, 3. Similarly, for this B, how many possibilities are there? 1, 2, 3. So there will be how many elements? 2 into 3. Because for 2% we have 3 possibilities, right? Similarly, for this n, how many possibilities are there? M. For each member of this set A, there are m possibilities. So how many members are there? N members are there. So how many possibilities are there? M cross n. So what is the cardinality of A cross B? It will be m cross n. So this is one thing. Okay. So what we have discussed up to this, we were saying why we are using this B. There is a possibility that I will use A only. Okay. So if some relation R is defined is a subset of A cross A, then we will introduce one another term is known as binary relation. So basically, what is binary relation? Binary relation, if some relation is defining from one set only, like A to A, B to B, this kind of thing happen. Or if relation is a subset of A cross A only. Okay. So in that case, we will say this relation is a binary relation. Okay. Any doubt up to this?
Sir, means it's between same set.
Yes. The relation, if the relation between same set, then we will say it's a binary set. It's a binary relation.
Okay, sir.
Any doubt up to this? No. Now, main thing
No,
which
sir.
can they which will they can ask in the exam is comes known as classification. Okay. Classification of binary relation. Like there are some types of binary relation. So I will write here classification of binary relation. So I will write here, okay. One type is reflexive. Have you heard this? Reflexive relation, symmetric. Okay, it's not like if some relation is reflexive, it cannot be symmetric kind of thing, okay. I'm just writing how many types of binary relation are there, basically. Or it's not classification, it's not correct word. We will say types of binary relation. Types of binary relation. So reflexive relations are there, symmetric, then anti-symmetric are there, reflexive, symmetric, identity relation. Okay, we'll come into the first only. Identity, then transitive, and some sort of relation is also there, but we don't need that. And lastly, equivalence relation. Okay, these are the major types. Some sort of relation is also there known as asymmetric relation kind of thing, but we don't need that much. Okay, just a second. Okay, this is the main part, right? Some question if they want to ask, they can ask here, and from the set, the question are like, okay, binary relation. Okay, identity, reflexive, symmetric, transitive, and anti-symmetric. Okay, so we will start with identity relation. Anyone have any idea about this? Identity relation. Also, for this this concept, I will solve one question. Okay, which are in your sheet as well. I have seen that question. Where is it? This one? No. There was one question no, for symmetric anti-symmetricity was there. I have seen that. Where is it? I have seen that question. Okay, I will solve that question as well. Now, up to this, everything is clear, or I have to increase my speed as well. Please let me know if you really feel that I am very slow. You can ask me. See, here is one question from this A cross B. So, what is this question? This question is saying if A and B are two sets such that the cardinality of A cross B is 6. Okay, cardinality of A cross B is 6. If three elements of A cross B are 4, 5, 1, 2, and 7, 2. What is the question? Okay, before starting this, we have the question. We have that A and B are two sets. And also we have the idea that the cardinality of A cross B is what? 6. Now, if the cardinality of A cross B is 6, then what are the possibility for cardinality of A and cardinality of B? So I need to find M and N integers such that this product will be 6. What are the possibility? 2 cross 3, 3 cross 2. Okay, this is for A, this is for B. And then 6 cross 1 and 1 cross 6. These are the 4 possibilities only I have, right? Right? This is the only possibility?
Yes.
Yes, sir.
Okay. Okay. Now, what is the next thing? The next thing is saying 4, 5, 1, 2, and 7, 2 are the members of this A cross B. Okay. Okay, sir. What are they? 4, 5, 1, 2, and 7, 2. Okay. 4, 5, 1, 2, and 7, 2. Okay. These are the member of A cross B. Now, from here, what we have seen here, since first member belongs to A and second member belongs to B, it means that what will be my A? 4, then say 1, then 7, right? These are the possibility. I am not saying this will be the element. There will be possibility that there will be one more element are there. But these are the possibility. This is not equal. But what to say? This will be the subset of it. That I can say, right? Right? This from here I know that this 1, 4, and 7 will be the element of A. That I know. And also similarly, what we can say 5 and 2 will be the element of B. Right? Now
Yes, sir.
see the possibility here. How many elements can have this set A? Either 2, 3, or 6. Here 3 is already there. Right? It means that this set cannot have less than 3 elements. So what are the possibility? The possibility is that either 3 elements are there, either 6 elements are there. Right?
Okay, sir.
Right? Now let's move towards this B. How many elements are there? 2 elements. So which one is the possibility? This possibility cannot hold because here only one element this B can have. Now, so only these possibilities are there. Right? It means that the cardinality of set A is my 3. The cardinality of set B is my 2. Now already we have seen that a subset which have cardinality 3 is a subset of A. It means that this A is nothing but 1, 4, 7 only, and this B is nothing but 2, 5 only. Right? Right?
Yes, sir.
Understood up to this? Any doubt?
No, sir.
No? Now, here from here you can easily find what will be my A cross B. What it will be? Please say.
1, 2.
1, 2, 1, 5, then 4, 2, 4, 5, then 7 comma 2, 7 comma 5. Okay, this will be my A cross B. Now here you can check which one is the correct answer.
Fourth one, sir.
Fourth one. Okay, this one will be my correct answer. 1 comma 2, 1 comma 5, and then 4 comma 5, 4 comma 2, 7 comma 5, 7 comma 2. Okay, this is one. Okay, this is the 18 question are coming from this reflexivity. Okay, we will see what is this reflexive thing, symmetric thing, and transitive thing. Did you know how to solve this A cross B question? This way is fine, right?
Yes, sir.
Explaining the concept and taking question from your mock test.
Yes, sir. Yes, sir.
So, have you gone through the concept? Have you gone through the question from mock test?
Not yet.
Yes, sir.
If someone has already done the mock test, at least what he can do, if I will explain some concept there, he will tell me that, sir, there are some question mock test. Please let me, please explain that one. So I will directly go. Otherwise, I have to see the each and every question from mock test. How many pages are there? 41 pages.
Sir, first one.
The first one from set.
Yes, sir. Right.
This is polynomial, no? We are right now. We are in set theory.
Okay.
Okay, we will go through the concept wise only. Okay, now up to this everything is clear, I guess. Okay, now let's move towards identity relation. Okay, before identity relation, what we have seen? We have seen that for binary relation, what we need? Okay.
Sir, question number 10.
Okay, question number 10 is from set theory?
Yes, sir. 12th page. Page number 12. 10th question, sir.
Okay, this is the question. Consider two sets are there, A and B. Defined as A is your AB. Okay, R cross R. Just take an R cross R, and it is defined like this. And B is also defined like this. Choose the correct answer. So we have seen what will be my A union B, what will be my A intersection B. Okay. So how will you solve this question? Any idea? Any idea? How will you solve this question? No? Anyone? Nice question, basically. Anyone have any idea? Guess? No? Let's see how we can solve it. So basically, what is my set A? Collection of pairs AB from your R cross R such that A minus 3 is less than 1 and B minus 3 is less than 1. Right? This is the collection. Now, how will you see this collection on Cartesian plane? So this is R cross R. Okay. So firstly, make the real line for one R, first one, and second real line for second one, known as x-axis and y-axis. Okay. This first line is belongs to this first member. The second line is belongs to this second member. Now it will be easy for me to check, right? First one is saying I need A minus 3, which is less than R. 1. Okay. So if I will open this, A minus 3 is less than 1, it means what? It will be minus this one. Right? Right?
Yes, sir.
Right, sir.
And how do you say this?
Yes, sir.
If absolute value of something is less than 1, what is absolute value? I am neglecting the negative things. If absolute value is less than 1, it means that what? That value
Mod.
that value should be inside 1 and -1 only, right? Should we lie in this interval
sir.
only, right? Okay. So here this thing will happen. So what will be the value of a? +3. It means what? Between 2 and 4, there will be some 2 and 4, right? Because I am taking A is as which interval? Which line? This horizontal line. Understood? This will be my A. From here to here, I can take A. Okay, according to this condition. Now, what about this B? I can. This is the reason for my A. Okay, this is the reason for my A. Okay, what about this B? Same thing is happen. Similar relation kind of thing is there. So if I will solve further, what I will get? Right? Same relation is there. Just replace B by A. So if same by similar manner I can solve. So if there is some B, there is some 2 and there is 4. So this will be the relation. So which reason is there? This relation only, right? This reason only, right? And
Yes.
boundaries are not included. Only inside portions are there. Understood?
Yes, sir.
What will be my A? Understood?
Yes, sir.
Okay, let's discuss about this B. So what is B?
Excluding boundaries.
Yeah, we are not including boundary because of this strictly inequalities. Okay, strictly inequalities. Okay, it's AB such that AB subset of R cross R and B minus something B minus 1 is less than or equal to A minus 3 whole square. Okay, so I have to decide this relation. So how will I decide? B minus 1 is less than or equal. Just open it. What it will be? A square plus 9 minus 6A.
6.
Then let's do further. Okay, or if I will see the another thing. Okay, if I will solve this equation, what does it means? Okay, let's try to solve this. A square plus 9 minus 6A is equals to B minus 1. Okay, before doing this kind of thing, let's see the options first. What are the options? Does A union B is B? Does A intersection B is 5? Does A union B is A? A intersection B is B. Okay. So for checking this A union B is B. Okay, we have to know about what will be my A union B. Sorry. If I will further solve here, what it will be? A square minus 6A plus 10 is equals to B, right?
Yeah.
Yes, sir.
Now, how will I approach further? So, if I want to see A intersection B, if I want to see this intersection, what it will be? It means that if something is there in this B, it has to be satisfied this equation and this reason as well, these two equation as well, right? Right?
Yes.
If something is there inside this, so it has to be satisfied this and this as well. Okay. Now, okay, if I will take this, so what will
We
This
can
is the
also
quadratic.
draw.
Sorry.
We can also draw a figure on the graph, sir. And
Yeah, we will
any
try
way-
to figure, but we don't know about this B, no. Firstly, I have to see the minimum value of B. Oh, sorry, minimum value of A.
It is looking like a parabolic equation, sir.
It's a
Very easy.
parabola. It's a
Yeah.
parabola. Okay.
Yeah.
It's a parabola. Yeah, it's a parabola. Actually, it's a parabola. A square minus 6A plus 10. So what will be its y in x in, thanks. What will be its y intercept? 10, right? As a is equals to 0, y is equals to 10. And what about x intercept? Oh, x intercept. It means that if I will put y is equals to 0 here, so I need to find the roots of this. What will be its root? 36 minus 40. No roots are there, right?
Yeah.
Right? This is determinant, no? Or discriminant. What is discriminant? B square minus 4AC. B is what? Coefficient of this. A coefficient of this. Basically, this is what? X square minus 6x plus 10. Here, A is my 1, coefficient of x square. B is by minus 6 and C is 10. So, if this thing is negative, then there will be no roots, right? Now, here we have seen B square is what? 36 minus 4 into A into C. So 4 into 1 into 10, it's 40. No intersection, no roots are there, right? Less than 0. So no roots. Right? Now, see the coefficient of x square. This I will teach, okay? Don't worry. This I will teach further in the quadratic portion. So the coefficient of this x is positive. Means that this will the parabola and it will open downwards and take its maximum value at minus b by a. Minus b by a, it means what? Minus plus 6 by 2a, 2 into 1. It means that at x is equals to 3, it will take its maximum value. Okay, so what does it mean? It means that, see, since this particular thing, where is it? This particular thing, if I will draw the graph of this thing, so it will be showing like this, no? This is like this.
No intersection.
No intersection is there, right? We have seen this graph. This is moving like this below the x-axis. This is my x-axis. It is below the x-axis, right?
Yes, sir.
How we are doing this, I will explain. Okay, I will explain in the quadratic portion so that you will understand this kind of thing. But currently, suppose that this is the graph. Okay, just let the consider this is the graph. Now, if this is the graph, this is the region where I am taking the value, and this is first region. So basically, this is my set B, and this not set B. Set A and B we are considering. Okay, yeah. So this is set B and this is set A. Is there any intersection in these two sets?
No.
No, right? So option 2 is be correct. Is there any doubt? Apart from this, how I made this graph, apart from this graph, any doubt? Please ask in this question. Apart from how I made this graph, please ask this. If you have some doubt, please ask. Okay.
Sir, one doubt.
Yes.
So in a set, can there be only unique numbers? There can't be any repetition.
No, there will be no repetition. You cannot write A. I missed that point. 1, 1, 1. You cannot write this. Write like this. Okay. This is not a set. There will be only unique thing. That is why we have written this well-defined thing. No? You cannot write Virat Kohli 2 times.
Okay.
So
Okay.
can you
Now here
summarize
you
the
cannot
answer?
consider this medicine box. There will be many paracetamol. No, but each paracetamol is separate from its right. Each paracetamol medicine is separate for another medicine. They are not same. Property is same. That is why
Yes.
they are inside this. No? But that will be separate, that will be inside the separate box, right? Separate packet, you can say, or separate packaging. Or if you see the paracetamol medicine, you will see like this. So each medicine will be in its separate chamber. Okay, though the property of both medicine is same, but still they are living in the separate chamber, right? They are not like this. In this chamber I am putting one paracetamol cell, the both kind of thing. Okay. Or someone will say, sir, we have seen the capsule box. Here, only one chamber, there will be so many medicine. Okay, it's not like that, but each medicine have its own property, right? The property is same, but their identity is same, right? The identity is same, but the individuality, personality, or whatever you say, that is different from another medicine. Thus, there will be some basic difference between size or something, right?
So it will be unique in its own way.
Yeah.
Right.
But in this case, 1 is equal to 1. Okay. There will be no uniqueness between, there will be no, like, there is no difference between this one and this one. So that is why we cannot put it here. But in this case, each medicines are, we cannot say this medicine is equal to this medicine. No, that is incorrect. There will be some minor difference, but there will be some difference. Okay, understood this question?
So could you quickly summarize the answer once again?
Answer is option B. Intersection is empty. Second option. Union will be not B. Why? Because if union will be B, it means that B, A will be the subset of B. We have seen there is not common intersection. Okay. Similarly, it cannot be A. Otherwise, B has to be subset of B, A. Or this intersection cannot be because we have already seen B is non-empty and the intersection is 5. So, second option is correct. Okay. Now, let's move further. Can I move further?
Sir, question number 18, page number 20.
Question number 18 is done, I guess. I have just done that question. Oh, this one, reflexive thing. This I will explain now. Firstly, I have to explain what is reflexive identity and all. Okay, we have to move a bit fast. Okay, basically, what is identity? Identity relation. So we have seen that R is a binary relation if it is a subset of A cross A. Okay. So suppose R is a relation. So identity relation, basically it is denoted by I. Okay. So I is said to be identity relation. First of all, it has to be relation. It means that this will be the subset of A. Okay. If and only if this I will be what? This I contains only pair of A for all A belongs to A. Or we don't need to include this for all sign. But this I will have only this kind of pair. For example, if you have A is equals to 1, 2, 3. Okay. Now what will be my I in this case? Anyone? This I will contain this same number, this pair kind of thing only. And this will happen for all elements of A. It means that
1, 1, 2, 2, 3, 3.
1, 1, 2, 2, 3, 3 only.
3, 3.
Okay. My question is that is there any element can come inside like 2, 3?
No, sir.
No. Why? Because of its property. It cannot have AB kind of element where A is not equal to B, right? It has only AA. It means that in each first and second place, there is only that person will only sit. Okay. What kind of relation it will be? Suppose you have a natural number set of natural number, this kind of thing, and you are defining equality relation, this equal to relation. It means that A and B is said to be this. Okay. we will say A and B related to this related with this B if and only if A equal to B. Then this relation R is basically what? Identity relation, because it has only A kind of thing. If A is equal to B, it means that. Understood? So this is an example of identity relation, this equality relation.
So if suppose two, 3 is in the set, in the identity set, then it won't be the identity set, and
Yes,
rather
if
it
2,
would
3
be,
is inside this set, this won't be the identity relation. For
so it will be
identity relation,
reflexive.
all the element has to be like this only, A.
So then it would be reflexive, right?
That we will see further.
Yeah.
That we will see further. But as of now, this is identity relation if and only if it will contain this A kind of element, and for all each and every elements are there. It means that pair like this happens, but this will happen for all the elements of A. It does not like that this 3 is missing for this I, and then we will say identity. No, for each and every member, this 1 1 2 2 3 3 or this A kind of thing are inside, has to be there. Then we will say it's a identity relation. Okay, it's not the case that this 2 3 is inside the this set, but we will say this is identity relation. No, this will not be identity relation. So from here we can say identity relation is always unique. If something is identity relation, it means that this is unique. It means that for one set there is only one identity relation. Okay, the representation of that identity relation is maybe different. Okay, maybe the represent is just like here it's a equality relation, from somewhere we will define by another relation, but what are the element will come through that relation. What do you mean by elements are coming through that relation? See, here the relation is this equality sign. According to this equality sign, what kind of element I am getting? This A kind of relation, right? Or here, if I will define this equality relation, so what kind of element I am getting? 1 1 2 2 3 3 kind of element, right? If I will define this less than or equal to relation, so from this relation, what kind of element I will get? A is less than B. So 1 2 I will get, then 1 1 is also I will get, then 2 3 I will get, and 2 2 I will get, and then further 1 3 I will get, and 3 3 I will get, right? But still, this is not identity relation. Why? Because it is containing 1 2 1 3 2 3 and 3. That's it. This 3, because of this 3 member, this will not become an identity relation. So for identity relation, only this A kind of elements are there, and this A will be for for each and every member from, which are inside A. Okay, I am giving another set B. Say what to say? Okay, okay, Mohan and Raghav. Okay, what will be the identity relation for this set B?
Mohan and Raghav.
Mohan, Raghav. Okay, understood. Understood?
Seems like mirror image.
Yes, sir.
Yeah, seems like mirror image. Or if you will see the R2 case, so it's like this y is equals to x line. Okay? Okay. So for R2, it means that R2 is R cross R. What will be the identity relation? Identity relation is not nothing but this y is equals to x line. Or we will say this xy, where y is equals to x. Okay? This line represents the identity relation is R2. Got the idea? Say something.
Yes,
Yes,
sir.
sir.
Okay. Reflexive relation. Now here I did like I relaxed up a bit, like I have okay, just a minute. Okay, so here I have removed some restrictions. Okay, so here the restriction was there will be no such pair like this. So in the reflexive case, what I am saying, a relation R is said to be reflexive. If and only if all the pairs like AA is inside R, not this R, for all A belongs to this A. What does it mean? It means that if some relation R is reflexive, it means that this contains all the elements like AA. Okay, but there is a possibility that some elements like AB are also inside this R. But for each and every element of A, for this, we will say all the elements like A has to be inside. This is the must condition. It has to be inside there. This R. Apart from this, if something is inside R, doesn't matter. If something is not inside R, doesn't matter. But for each and every member of A, this A pair has to be inside R. Understood? For example, if I have set A is same example 1, 2, 3, then what will be the reflexive relation? 1, 1, 2, 2, 3, 3 has to be inside R. Okay, for each and every member of A, this kind of pair has to be inside R. Apart from this, if 2, 3 is also inside R, doesn't matter. 3, 1 is also inside R, doesn't matter. Okay. If they are not inside R, doesn't matter. Got the point? When we will say some relation is reflexive, if this pair is inside R, then we will say for every element of A, then we will say it's a reflexive relation. Apart from this member, if something is inside R, doesn't matter. If something else not inside R, doesn't matter. So what is observation? It means that identity relation is always a subset of R if R is reflexive. Right?
Yes,
right?
sir.
So another definition is comes into the picture. R is said to be reflexive if and only if my identity relation is a subset of R. Okay, this is another definition. Understood up to this?
Yes, sir.
Okay, now transitive. Transitive relation is saying if my AB pair is inside R, okay, here if and then what this condition are coming into the picture. If this AB is inside R, then this BA has to be inside R. What does it mean? It means that I am saying this pair is inside R. It means that A is related with this B. Then if this is a symmetric relation, then it means that this B has to be related with A. Okay.
Yes.
Suppose Rohan is my brother. Rohan is brother of A, Arpit. So it means that Arpit has to be brother of Rohan as well. It's not like Rohan is considering Arpit as brother, but Arpit is not considering Rohan as brother. Okay, it's not like that. If this is a relation, a symmetric relation, means that if Rohan is considering Arpit as brother, Arpit has to be considered Rohan as brother. Okay, but there is a possibility. Now, someone will say, sir, can we say this will happen for all the elements which are inside A? No, if something is inside R, then we will check whether this condition hold or not. This condition hold or not. If something is not there inside R, then we don't need to worry about it. For example, if you have set A is equal to same example 1, 2, 3. Okay, and we have R is like this 1, 2, 2, 2, and 2, 3, like this. Okay, now check for 1, 2. Let's go towards 1, 2. Okay, we will not worried about 1, 3 and 3, 1 kind of thing. Why we are not worried about it? Because we have to see only the member of R. Okay, here we have seen if something is inside R, for which this has to be inside R. Okay, if something is not inside R, we don't need to worry about it. So now here we have seen that this 1, 2 is inside R. Now since 1, 2 is inside R, so if this R is a symmetric relation, means that for that 2, 1 has to be inside R, right? If it is not, then it is not a symmetric relation, right? So here see 1 2 is inside R. For this 1 2, is there 2 1 inside R? No, right? 2 1 is not there.
No, sir. No, sir.
It means that this is not symmetric relation. Suppose I have given 2 1 is also here. Now 2 1 is there. Now let's move towards 2 2. Now for 2 2 inside R, here A and B both are same. So 2 2 inside R, we don't need to worry about it, because if I will replace, interchange the place, doesn't matter, 2 2 I will get the same. Now, so I don't need to check for same element. Now let's move towards 2 1. For 2 1 inside R, is there 1 2 inside R? Yes, here for 2 1 inside R, 1 2 is inside R, right? Now
Yes,
let's
sir.
move towards 2 3. For 2 3 inside R, does the 3 2 inside R?
No, sir.
No. So again, this is not symmetric relation. Now I have put 3 2 also. Now does it is symmetric relation now? Yes.
Yes,
Now
sir.
it's a symmetric relation. Now here someone will say, sir, we didn't check this 1 3. We don't need to check this 1 3 because 1 3 is not inside R. Okay, understood? When we sorry,
Again
this
that point.
symmetric
Again
relation.
that
I have
point.
right here transitive and I am explaining symmetric. Okay, this is my mistake. This is symmetric. Okay, I am explaining symmetric and right. I have written here transitive. Symmetric. Now it's clear. So when we will say it's a symmetric, if for
Sir, last
AB,
point one more time, sir.
sorry.
And you explained about 1 3. Can you explain it again?
1 3, yeah. So why we are not checking for 1 3? Because 1 3 is not inside R. When we have to check for a pair, if the pair is inside R, then we have to change its reverse part. Does BA is inside R or not? If something is not inside R, we don't need to worry about it, right?
Okay, sir.
Suppose, for example, for your regular life example, you want to make tea. Okay, you have to make a tea. How many material you want for making a tea? You need water, right? Then milk, then sugar, then tea leaves, right? Right?
Yes, sir.
Now, if I will go to the kitchen first time and I need this product, does I will find where is chili kind of thing? Does I will find where is salt? Does I will find what to say? Okay, so unnecessary cheese I will not going to check, right?
Yes, sir.
Same thing is there. If I need, I have to check for only the member of R. Why I will be worried about this 1 3? 1 3 is not the member of R. I don't need to check. I need to check only for member of R only. Understood? For symmetricity, symmetric relation. Okay.
So, sir, if that relation has only 1 2, 2 1, and 2 2, so still we can say it's symmetric, right?
Yeah. One more example you can say, if R has 1 2, 2 2, and 2 1, then again we will start from this first element. 1 2 is inside R, so we will check for this 1 2. Does 2 1 is inside R? So we are checking here. Yes, 2 1 is inside R. Now delete those two. Don't need to check, because if for this inside this, so this inside this, both are done. Now let's move to another one. 2 2. For 2 2 is inside 2 2. For 2 2, yes, 2 2 is also inside R. Both are same thing. So this is also done. So for every element which are inside R, their opposite part is also inside R. So this is a symmetric relation. Okay.
Okay, sir.
Okay. Now let's move to towards anti-symmetric.
So do we define all these kinds of relations between two different sets, or we only define within a single set?
Sorry?
Do we define all these identity, symmetric, reflexive relations between two different sets? Or
No. We are defining for binary relation only. Same set.
Only
Same
binary.
set.
Okay.
That is why we have right types of binary relation, right? Initial here.
Okay.
Okay, antisymmetric. So antisymmetric is saying basically it is saying if AB is inside R, okay, and A and B both are not equal, then it is saying then BA are not allowed to be inside R. Okay, what I have what I mean to say, suppose these two elements are, suppose 1 2 is inside R. Okay, here we have seen this one is not equal to this one. Then if both are not equal to each other, then we will say if this person is inside R, so we are not allowing this person has to be inside R. Okay, so understood this concept, right? We will see if something is inside R, then we will see both are equal to each other or not, both member are equal to each other or not, first member and second member. If they are not equal to each other, then we will say its symmetric part is inside R or not. If it is inside R, it's not antisymmetric. If it is not inside R, for each and every member of R, then we will say it's an antisymmetric. Okay, for example, same thing, if we have 1 2 3, then we will say, okay, suppose R is my like this 1 2 2 2 and 2 3. Okay, let us check for 1 2. For 1 2, 1 is not equal to 2, right? So we have to check whether this 2 1 is inside R or not. If it is inside, if it is not inside R, then we will allow R to be antisymmetric relation, right? You can think it's kind of negation of symmetric relation, but it's not, because I will give you an example which is symmetric and antisymmetric both. Okay, don't worry, I will give you an example, but you can think like that. So 1 is not equal to 2, so we have to see whether this 2 1 is inside or not, R or not. It's not inside, so check. Now here both person are same, we don't need to check, so we will move further. For this 2 3, 2 is not equal to 3. Now let's check whether 3 2 is inside or not. It's not, so check. So from here we will say R is antisymmetric. Okay, any doubt? Any doubt
No,
up
sir.
to this? No?
No,
No, right?
No, sir.
Now,
So 2
I
2
will
is
give you
allowed,
an
sir.
example.
2 2 is allowed, right?
Sorry, 2 2 is
2
allowed
2 is
because,
oh.
because here we are saying if not equal to, for equal to B, we don't need to check. It is allowed.
Okay, sir.
Okay? Okay. So I will give you an example. R is equals to 1 1 2 2. Okay, this is an example. Same set. A is equals to 1 2 3. Okay, let's check. So this is satisfying the antisymmetricity, because for those all the member both person are same, here same. So this is antisymmetric, right? Antisymmetric.
Yes. Yes, sir.
Now what
It is
about
antisymmetric.
it is symmetric or not? So for 1 1 belongs to R. Let's check its reverse part. It is also inside R because both are same. Similarly for 2, so it is symmetric as well, right? So it's not like if some relation are antisymmetric, it will not be symmetric relation. Okay, a relation can be both symmetric and antisymmetric. Okay, as well. Okay,
Yes,
understood?
sir.
Is there any confusion between symmetric and antisymmetric? Please ask.
No, sir.
Okay, let's go further. Transitive relation. Transitive relation. Okay, what is transitive relation basically? Transitive relation is saying if AB is inside R and, okay, remember this, and PC is inside R. then AC has to be inside R. What does it mean? Means that if this pair and this pair, see this entry, these are same. Okay, so if this kind of pair are inside R, then this person and this person, the pair of this person and this person has to be inside R. For example, we will say same set 1, 2, 3. If R is my like this 1, 2, 2, 3, 1, 3, 1, 2. Okay, now I need to check whether this relation is a transitive or not. So we have to check for firstly for AB and BC kind of elements are there or not. So just closely observe here 1, 2 and 2, 3. See, this is its second place, its first place are sent. So this kind of elements are there. So 1, 2 and 2, 3 are there. Now for these two person, I need to check this will be first place, this will be second place. 1, 3 is inside R or not. So here 1, 3 is there. Now satisfied. Now check for 1, 3. Is there any element from for like 3, 1? No. So I don't need to check. Here 1, 2. Is there any element like 2, 2 or something? No. So I don't need to check. Okay. If this kind of elements are inside R, then for which this AC is inside or R or not, that we have to check. Okay.
So if any one pair is like that, that is fully considered to be transitive, sir.
Yes. Sorry.
If you have said 1, 2, 2, 3, and 1, 3. So if if it satisfies in any of the
not any, if there is some more kind of element here, if 2, 1 is also there, suppose that for any R1, in this case, suppose here I am including 2, 1 as well. Okay, here 2, 1 is also the member of this one. Now we have seen that this place and this place are matching. Also this place, this person for this person and this person are matching. Now I have to see firstly for this person whether 1, 1 is inside R or not. And this is for this also 1, 1 will be the same. So if you will see for this person 1, 1 I have to check now, because here its second member and its first member are matching to each other, right? Similarly this. So whenever you will get this match in this set R, you have to check this match is inside R or not. That's it. If you are not getting this match, you don't need to worry about the another match. If you are getting this match, you will go to further. If you are not getting, you don't need to worry about it.
Okay, so if any of
sorry,
Salome, go ahead.
Thank you. Sir, it means we have to be in order only.
Yes, we have to see the or
It
this kind of
cannot be
order.
CA.
Sorry.
So it cannot be CA, na? It should be A and C only.
Yes, yes,
Order
yes.
should be
It
A.
cannot be ACA. It will be AC only. That is why I have written ACA. No? Otherwise, or I will write CA. I am not writing this. It means what? This is not.
Thank you, sir.
Okay. Now we have done all type of relation. So lastly, we have equivalence relation. Valence relation. So what is equivalence relation? Basically, equivalence relation, a relation is said to be equivalence if R is said to be equivalent if it is reflexive, symmetric, and transitive. If some relation is this three kind of thing, they are following all the three relation, reflexivity, symmetricity, and transitivity, then we will say it's a equivalence relation. Okay, that's it. This is the definition only. Now let's move to our example. We have this question. Consider the relation R is like this on the set of real numbers. Okay. Then we have to see whether R is reflexive relation, whether R is symmetric relation, whether R is transitive relation or not, whether R is equivalence relation or not. Now, how will I check?
Sir, I have one doubt. For equivalence means R should be reflexive, symmetric, and transitive.
Sorry.
Sir, means equivalence. Equivalence relation means R should be our reflexive, symmetric, and transitive. Means
Exactly.
all all three conditions should be true.
Yes.
Thank you, sir.
Okay. We have relation R. Basically, what is it? We are collecting all those a pair of xy from R to R cross R such that its absolute value, the difference between x and y, it should be greater than 0 and less than 2. Okay, this is the relation. Now let us solve this. What is this basically? So here, first of all, we have x minus y is less than 2. It means what? Minus 2 x minus y plus 2. This is what we have. Or if I will multiply with minus, what I will get? Minus 2 less than y minus x. So it is what? X minus 2, x plus 2. So if I will draw the reason, so what it is basically? So which one is the y is equals to x plus 2 line? If I will put x is equals to 0, I will get y is equals to 2 somewhere here. This is 2. If I will put y is equals to 0, I will get x is equals to minus 2 somewhere here. So this is the line, right? This is the line for y is equals to x plus 2. What about y is equals to x minus 2? For y is equals to x minus 2? What it will be? If x is equals to 0 here, I will get y is equals to minus 2 somewhere here. And if I will put y is equals to 0, I will get x is equals to 2 somewhere here. Y is equals to x minus 2. Okay, so from the first condition, what I get? I get, what to say? This reason, na, basically. This reason, between this line and this line, I need greater than x minus 2 line. It means that this portion, and less than x plus 2 line. It means that this portion. Between these two line, right? Right?
Yes, sir.
Yeah.
Yes, sir.
Okay. Okay, now another constraint is x minus y is greater than 0. Greater than 0, it means what? Either x minus y is less than 0 or x minus y is greater than 0. Okay, this is the condition that we have. So from here, y is what? Either y is greater than x or y is less than x, right? So I need to make the line y is equals to x. So which one is the line y is equals to x? This
Passes from the origin.
Passes from origin. But I need this strictly inequality. It means that I am excluding this line, right? I don't need this line. So basically, if I will exclude this line in the whole region, then I will get my desired set R, right?
Yes, sir.
Right? I don't need y is equals to x here because I am taking strictly inequality. If there will be equality sign, then there will be no such there will be no such use of this constant, because absolute value is always strictly greater than or equal to 0, right? So what is the use of introducing this strictly inequality here? Because I don't want y is equals to x line here. So since y is equals to x line is not here, it means that from here also I can say this is not reflexive relation, not reflexive, right? Right? From here
Yes,
itself
sir.
I can say it's not
Yes,
reflexive,
sir.
right?
Yes,
Right?
sir. Yes, sir. Yes.
Because this is not containing y is equals to x line. If this is reflexive, it has to be contain y is equals to x line, but this is not containing, it's not reflexive. Now see the question again. If it is not reflexive, it will not be equivalence as well, because for equivalence, reflexive, symmetricity and transitivity, all has to be satisfied,
Yes, sir.
right? Now what I need to check, I need to check transitive relation, symmetric relation and transitive relation both, right? Okay, let's see
Yes,
for
sir.
symmetricity. So symmetricity is what saying? What it is saying? If some xy is inside R, for this, for that yx has to be inside R, right? So suppose I have xy as 1 0. So what will be my yx? It will be 0 1 kind of thing, right?
0, 1. Yes.
It means something is there. It has to be there. Or suppose I have something like half and 3 by 4. Okay, so where will be half and 3 by 4? Half and 3 by 4. Somewhere here, right? So what I need? 3 by 4 and half. I am just switching these two elements, right?
Yes, sir.
Now, from this relation also as well. If xy inside R, if I will take y minus x also, because of this modulus, is there any change will happen here? No, right? Because of this modulus, I can write it as either I can write x minus y or y minus x, doesn't matter,
Yes, sir.
Yes.
right? Even I can write it as x minus y, y minus x, it doesn't matter. It means that this is symmetric. This relation is symmetric, right? From here I can see, because of this modulus, if I will write y minus x, see here yx means what? This y minus x is greater than 2 and less than 0. Sorry, it's greater than 0 and less than 2. Right? So if I will switch these two elements, I don't need to worry about, I can switch directly, right?
Yes, sir.
Okay, simple. So it's a symmetric relation. Means that option 2 is correct. Now I hate to see, because it's a MSQ question, it means that more than one option can be correct. So I have to see whether this option 3 is correct or not. Means that if the relation is transitive or not. Okay, how will I check transitivity? So it is saying if something xy kind of thing is inside R and yz kind of thing is also inside R, then I need to check whether this x
X
z
or Y.
inside R or not. That I need to check. Okay, how will I check? Okay, take this boundary element, this boundary element. So this boundary element is what? 2 0, and this boundary element is what? 0 2, right? So here we have seen that this boundary element is inside R or not? No, right? It's not inside R. Okay, because this boundary we are not including because of strictly inequalities. So I am not taking this boundary. Okay, take a element from here and here. Means that I am taking 1 0 from R and 0 1 from R. I can take, right?
Yes.
Or it's reverse parse. 0 1 belongs to R and 1 0 belongs to R. Okay. For here we can say if this is transitive, then 1 1 has to be inside R. This, right?
Yes, sir.
But 1 1 is not inside R. Why? Because 1 1 is lying inside this line, but this line is not inside R. Or we can say if 1 1 is inside R, then what will be my y minus x? It will be 0 only because y and x both are equal, but 0 is not
Yes, sir.
inside R. Because this relation has to be strictly greater than 0, but here we are getting equality. It means that this is not
Yes,
transitive
sir.
relation, right?
Yes,
Yes.
sir.
What the idea? How you are checking this kind of thing?
Yes, sir.
Yes, sir.
Okay. Now I am giving you 2 minutes break. Okay. Don't worry, I will finish. So what I will do? Shall I have to introduce this line equation because this is just a what there will be just a formula based kind of thing. Okay. You can directly see and then see how to solve this kind of question. Yeah, one thing that I will explain in that particular in that thing, there is some squared error. Okay, that I will explain because this the one question can come from there and that is important. So some square some error, someone will say some square error, that I will explain. But other what are the things are there like formula based thing, that I will not going to explain. Okay, well, will it be fine for everyone?
Yes, sir.
Formula based thing you can learn, right? Conceptual thing I will explain.
Yes, sir.
Don't worry. Because this thing I cannot cover all those things in just 2.5 hours. Right? I am expecting that because you are a debt qualifier student, so I am expecting the thing that you have already learned those kind of thing in your past. So that is why still in the relation part, I have went in a very slow pace because in 1.5 hours I have covered only relation, but still no issue. Okay, so I will skip those portion equation of line kind of thing. Okay, will it fine for everyone? It's just a formula based thing. They will say, well,
Yes,
if
sir.
I will give you 2 points, what will be the distance? Wow, what is the distance between these 2 points? You have to just apply the uh, formula x2 minus x1 is whole square plus y2
Yes, sir.
minus
Yes,
y1
sir.
square. This kind of thing is there. Just the formula based question. That's it.
Yes, sir. Yes, sir.
After this 2 minute break, I will explain the definition of function. What is function basically? Okay. Shall I have to explain
Yes,
this?
sir.
If yes, I will explain what is function basically. So what is function? It will take barely 15 minutes for function. I will not go into depth of the function. I will just tell you the definition of function, and then I will move towards quadratic functions, and then polynomial function. Barely it will take 1.5 hours. I will wrap up by 11:30.
Okay, sir.
Okay, sir.
Okay. Okay. That's why I'm giving 2 minutes break, and I need water as well. Hello? Okay. Am I audible?
Yes, sir.
Yes, sir.
So I had a question.
Yes.
So like all set theory and relation questions, do we solve by using like the Cartesian plane itself, or is there another way of solving?
Sorry, all the
Like all the set theory and relation questions, do you want is there any other way of solving, or do we have to use the Cartesian plane and then graph it and then see the solution?
it depends on the question as well. Sometimes you don't need to go with Cartesian plane and all. Sometimes there will be some straightforward question from set theory. It depends on the question. We cannot say. Sometimes you have to use the graph. Sometimes you don't need to use the graph. But in both of the question, you need a graph. Okay. There are some other question. Okay. For that, you don't need to see the graph.
Okay, thank you.
Okay. It depends on the question. The what thing is matter? Your concept is clear or not.
Yes.
Okay. This is the only thing that matters. If your concepts are clear, you don't need to worry about it. Your concepts are not clear, then you have to think about it. Either because simple question you cannot do if your concepts are not clear.
Yes, sir.
But if your concepts are clear, then at least you can fight for hard question as well.
Okay, thank you, sir.
Okay, let's start with function. Anyone have any idea about functions?
Not much, sir.
Okay. Anything you know about functions? What is function kind of thing? Anyone? I'm not asking for a specifically one person, but yeah. Any idea?
The special beauty of a thing.
Sorry?
The
Voice is
special beauty of a thing.
okay, let's see. Let's see what is function basically. Basically, function is nothing but function. We will denote function as f is a special type of relation. Okay, special type of relation. What we have seen that if something is a relation, for that we need a set A and we need a set B. From where to where we will define a relation, or sometimes we will say this is a subset of A cross B. Why we will say this is a subset of A cross B? Because through this relation we are relating this one member from this member to another member from this member, right? Right. So similarly, function is what? Function is also a special type of relation. What kind of property that function has to be followed, I will write. Okay. So basically, function is nothing but it's also a relation. So what he will do, this will take something from this set A as input, and after doing some magic kind of thing, and it will provide some y in this output. Okay, and we will say xy which are related with this f. Okay, f. So rather than writing this kind of thing, I will go with this. Okay, so from here we will say this x and y related with the function f. How it is related? It is related like this. If I am applying this f to on this x, then I will get this y. Okay, just like chips making machine. Have you seen? If you will throw the potato inside the chips making machine, I will get the chips. Same thing is happening here. If you will throw this x inside this f, you will get this y. Up to this clear?
Yes, sir.
Right now, so for that you need some input set. this set, input set, this thing is known as domain. Okay, the set is known as this set A, from where this function f is taking input, is known as domain. This is known as codomain. Codomain. Okay, if function is defined from A to B, it is known as codomain. And collection of all output is known as set. Sorry, not set, range. Okay, this input set is known as domain. From where function is defined, this set is known as codomain. And all the output, if I will collect all the output, this known as range. So we have seen in the relation part as well, there is a possibility that all the members of B are not included in the relation, right? Right? And similarly, all the element of A also may be included or maybe not included, right? Maybe a part of relation or not. There is a possibility, right? So in the relation, what we have seen that there may exist some element in set A and B both, which are not the part of relation, right? Right? In the relation, we have seen this. There may exist some element in A and B both, which are not the part of relation, right? Right? Say something.
Yes, sir. Yes, sir.
Okay.
Yes,
Okay.
sir.
And one more thing that we have seen is that there is a possibility that if A is inside this capital A, then A is related with B as well as A is related with this C, right? Right? This thing also we have seen in the relation. If something is inside
Yes,
A,
sir.
for which this can be related with B and C at a time, at a particular time, this is a possibility that we have seen.
Yes, sir.
Right? It means that, okay, one more thing that I have to include, this for this X, this Y is known as image of, we will say Y is the image of X, and this X is known as pre-image of Y. So we will say X is a pre-image of Y. Y is the image of X. X is a pre-image of Y. This is the notation. Okay. Name. Just we have given a name. Okay. Now, so what is the difference in function? So function is saying, we will say any relation F, which is defined from A to B, is a function if and only if initially F is a relation, then this relation F is said to be function if and only if firstly each element of A, say A belongs to A, has image in B, image in B. Okay, which means that this A, if this is my A, say 1, 2, 3, 4, and this is my B, A, B, C, D. Okay, so in this through this relation F, or through this relation F, every person will get its image. Okay, for every person there will be some image. Okay, 1 there will be some element which are related with this one. For 2 there will be some element in B which are related with 2. For 3 there will be some element which are related with this 3, and for 4 there will be some element which are related with 4. Understood up to this? It means that there will be no and like there will be no such element inside A which does not have any image in this B. Okay, it means that all the element will be busy with some element of B. Okay.
Yes.
Okay. Now, second rule is saying if if our element A is busy with this B, then this A cannot busy with another element C if B is not equal to C. What I am saying, suppose this A with A is already related with one is already related with this A, then it has to be related with this A only. It cannot go with this B. It cannot go with this C. It cannot go with this D. It does not have that right. With that, each element of A, got the idea?
Yes, sir.
Means that here one element cannot meet with two elements. They cannot cheat to the another person. Okay? They has to be meet only one person. And definitely they will meet to one person at least. They will meet to one person. And that person should be unique. That person cannot change. Got the idea what is the difference in function and relation?
Yes, sir.
Okay, so it's a special type of relation which follows these two property. First property is known as each element of A has image, and second property is saying that image should be unique. Got the idea? But there is no restriction on B. There is a possibility that this 1, 2, 3, 4 can meet only one element, A only, and BC will be they does not have any pre-image. There is no restriction on this B. Okay, the restriction only the domain set only. Okay, got the idea? Each element will have image, and if A will one will get some one image, it cannot have another image. If it has one image, it cannot have another image. Okay,
sir, please relate this with taking example of f of y equal to x square.
Yes, I am taking. If you have fx is equals to x square.
F of y.
F of y is equals to x square. How is it? Here you are taking something in the domain as y, so input as y, and you are getting output in terms of x. There is no relation. Then it will become a constant function. This will behave like a constant. This will not.
Okay.
There is no term of y, right? If you are taking something as input, there should be some terms of y. Otherwise, that function will treat it as constant function. Understood?
Yes, sir.
Okay. So basically, understood the idea? For example, fx is equals to x square. Okay. So if I will say this is a function or not. Okay, I have made a graph. So I am saying this is a graph and this is my domain. Okay, here to here. So this is the function or not. So what you need to check? If this is a domain, say AB, so you need to check for each member of this domain, I am getting image or not. So I choose this member. So for this member, there is one image, only one image is there, right? Means that this vertical line should cut only one place of this graph, right? If I will take any arbitrary point here, I will draw a vertical line, then I will say this is also cutting only one place. So it's a function, right?
Yeah.
Yes.
And for each point of this domain, I am getting a vertical line, which is cutting my graph uniquely. So this is a function. Now another example, if I will take, suppose this is another graph. This is what? Y is equals to x square graph. Now, does this is a function? I am defining my domain from this 0 to infinity. Is this a function?
No.
No, right? If I will take any element here, I will get two images here and here. Right? For one element, for one input, I am getting two images. It is x is equals to y square, right? This is a graph of x is equals to y square, not y is equals to x square. Okay. Okay. So why it's so? So your x is having element x can come from 0 to 1, no 0 to infinity. So for 1 is belongs to this domain. For 1, y can be +1 and -1 both, right? So if I will check f of 1, so f of 1 can be 1 or f of 1 can be -1, right?
Yes, sir.
Yes.
No, I'm committing some mistake, I guess. So here what I will get, y is equals to plus minus x. So basically, if I will put x is equals to, I need plus minus y. So for one value of x is equals to 1. Okay, let me see. This is graph of x is equals to y square, I guess, right? For y is equals to -1, I will get x is equals to 1. Yes. For x is equals to 1, I will get y is equals to plus minus. Yeah, this is correct. Okay, so did you observe the thing here? What is wrong with this example? For one input, I am getting two different output, right?
Yes, sir.
Yes, sir.
Yes, sir.
So this is not a function. Okay, now
That's why I am confused in this, sir. Okay.
yeah, so here you will say now y is equals to plus minus x. So plus minus root x. So what will be my fx? Fx is plus minus root x. So if you will put x is equals to 1 here, so what you will get? F1 is equals to either +1 or -1. So there are two different outputs, no? Right? Now understood? Hello?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, then what text? Okay. So this is functions. Okay, okay. Have you idea about one-to-one function? On-to function? Any idea? Have you heard this term? Injective function, surjective function, or one-to-one function, on-to function, bijective function?
Yes, sir.
Do I need to explain this as well? If you want me to explain, please let me know. Otherwise, I will move towards quadratic functions.
We want this, sir. One-to-one, on-to-one.
Okay, one-to function is what? One-to-one.
Short summary, sir.
Yeah, short summary I will get. Injective function. Okay. What does it mean? See, here we have restricted this relation with domain only, right? Right? We have done this to restriction in the domain for being a function. Now, I am going with this codomain. Now, here I am saying if all the element of B, okay, all the element of B have pre-image in A, it means that here we have seen that this range is a subset of codomain. Why we are saying it as range is what? Basically collection of output, right? So here if all the four element will map A, so how many outputs I will get? I will get only one output. So what will be my range? Range will be my A only. Now what is my codomain? Codomain is what? This bigger set B. this B. So we will say range is always a subset of codomain. Now what I am saying, if this range is equal to B, means that all the element of this B have pre-image in A. It means that there will be no free element in this B, or all the element of B is related with this A, then we will say, okay, another onto function. Okay, I am firstly explaining onto function, surjective. So if a function is defined from A to B such that for all y belongs to B, okay, for all the elements which are inside B, there exists an x belongs to A such that fx is equals to y, then we will say f is surjective or onto. What does it mean? It means suppose this is my A, this is my B. Okay. So for a function has to be defined, each element of A has some pre-image in this set, and that have some image in this set B, and that image has to be unique. That we have seen in the definition of function, right? This image has to be unique. Now what the surjective function is saying, surjective function is saying they are giving some advantage to codomain, and they are saying if for each element in codomain, if I will have pre-image in B, it means that there exists at least one element. Why I am saying at least one element? Because two element can also map to one single element in B, right? So if there is at least one element in A for which the image of that element is that element Y, then we will say this is surjective relation. It means that there will be no free element in this B, or we will say codomain equal to range. Then we will say this is a surjective function. Got it?
Yes, sir.
Got it?
Yes, sir.
Okay. So what is injectivity? So from the second part of the definition of the function, here what I am saying, if fa is equals to B, then fa cannot be equal to C, B is not equal to C. Similarly, this similar thing we will apply in the codomain part as well. It means that if this is B, so what is injective function basically? Here two distinct element of A cannot meet with only one element of B. Initially in the definition of function, what we have seen there is a possibility that two elements of A can meet with one element of B, right? There is a possibility because we have restricted with set A. What is that restriction? That restriction what this person cannot have two distinct image in B, but there is a possibility that two distinct element of A can meet with single element of B. But in the injectivity case, we are not allowing this kind of case. We will say if function is injective, then each member of this set A will have separate image. It means that two distinct element of A cannot meet with single element of B. Okay, this kind of case will not happen. Got the idea? Okay, only this kind of case will happen.
Yes.
Right? So this is on to function. I have given you the just brief idea about injectivity and surjectivity. There are much things which are inside this, but I am not going to that. I am just explaining what is it. Now, last time is bijective function. So what is bijective function? Basically, bijective function is nothing but if a function is injective and surjective both, then we will say that function is bijective. Okay. For example, fx is equals to x. If f is defined from R to R, then this is a injective and bijective both. How we will check this is a 1-1 function or not? So for checking this is 1-1 or not, we are saying let's take x1 and x2 from R. Okay, we are taking two distinct elements. Okay, so what I need fx1 not equal to fx2, right? Right. This will I need now. If I am taking two distinct element for which if I am getting this, then I am done. So if I will take fx is equals to x and x1 is not equal to x2, then obviously fx1 will not equal to fx2, right? Because this is what? This is my x1. This is what? My x2. So this is are not equal to x1 and x2. Got it?
This example, can you explain again, sir?
Okay, this is a bit confusing. Let's take fx is equals to x cube example. Okay, I need to check whether this function is 1-1 or not. I am taking two distinct elements which are not equal to each other. Okay, now my assumption that f is not 1-1. Okay, I have to prove f is 1-1, but I am assuming that f is not 1-1. I am going with contradiction part. Contradiction. Okay, not 1-1. If it is not 1-1, then there exist two distinct elements x1 and x2 which are not equal to each other, for which fx1 is equal to fx2, right? If this is not 1-1, at least there will be some two elements for which the image will be equal, right? What it means? Means that there will be two element in A for which this element will meet with one element, right? This is x1 and this is x2, and this is fx1, which are equal to fx2, right? This will happen, right?
Okay, sir. Yes, sir.
Right? So I am considering this is not 1-1. So this will happen. Now function is my x cube. So this will be x1 cube is equals to x2 cube. Right? Now, what it will be? X1 cube minus x2 cube is equals to 0. Now, if you will break it further, it will be what? X1 minus x2, and this will be x1 square plus x1 x2 plus x2 square is equals to 0. Now, this is positive always. Okay, this will be positive always. So what it will be?
X1
has
is
to
equal
be
to
x1 minus x2 is equals to 0. From here you will get x1 is equals to x2. But initially we have taken it as not equal to each other. Contradiction. It means that f has to be 1. Okay.
Okay, sir.
So this is 1-1 function. So this is the one way that you can check this function is 1-1 or not. Now, any doubt up to this?
No, sir.
Okay. Just a minute, okay. Okay, actually my friend is getting married and he is just 23-year-old. He's a boy, first of all. Can you imagine that? So he is sending me message, please come, please come. He is very desperate with his marriage. Okay, so function part is over. Now let's move towards quadratic equation. Still, there are many things which are inside the function, but I am not covering because of lack of time. Okay, many things are there. So you guys don't have any live session, right? This is your first live session, I guess. Or is there any live session?
Yes,
Yesterday there was
we
statistics.
don't have no life.
Yesterday there was statistics, sir. Today is a math first time.
Okay. So how will you guys managing this kind of thing?
So they provided us some playlist and we have to study from that only.
So the best way for you guys for watching the lecture only, right? Is there any TA session kind of thing for you?
What is that, sir?
TA session, teaching assistant kind of thing.
No.
No.
I don't think so. We didn't do anything like that.
Okay. So okay. Okay. So
But actually, speaking sections are very, very useful.
sorry.
These sessions are very, very useful.
Okay. If you want, you can join to your regular session, right? Not your regular session, but the diploma level session that are conducting in each week basis. So if you want to join, you can join there as well, right? There will be some YouTube links. So through that links, you can join the session.
But we are not getting any informations about it. So where we will get the information?
Oh, that's the thing. Yeah. I think you can get this from YouTube channel itself, but there is some uncertainty. Like there is a possibility that like when the session will happen, this is the difficulty, right? Because checking each and every day is difficult.
Invitations are not
So
coming.
we don't have the timetable.
For that, you have to check each and every. Basically, the session of Math 1 is happening on Friday, Sunday, and Tuesday basis. Same class. Friday session will be in the morning, 7 o'clock, and all the session will be 8:30 or 8 like that only. Same stats one something. Okay. So this is your first exam, right?
Yes, this is a qualifier exam.
Okay. So you have to score well, all the very best for this examination. Please work hard.
Thank you, sir.
Quadratic function. What is quadratic function? Any idea? What is quadratic function basically? Any idea? Basic things? Okay. So if a function will look like this, a 2-degree polynomial, where a is not equal to 0 and b and c are arbitrary, or we will say it belongs to R. For you guys, it's a real number. Or someone will say a and b can be anything, a, b, c can be anything, but the condition is that a is not equal to 0. Then f is said to be quadratic function. Just a definition. Okay. When we will say f is a quadratic function, if f is like this, ax square plus bx plus c, there is not equal to 0. Sorry. It's a 2-degree polynomial. So this function is known as quadratic function. Similarly, what is polynomial function then? If a function will look like this, ax raised to the power n, here x raised to the power is 2 is there. So here ax raised to the power n, bx raised to the power n minus 1. So here rather than using a, b and c, what I will say, an x raised to the power n plus an minus 1 x raised to the power n minus 1 plus like this a1x plus a naught. Okay, where an is not equal to 0 and all the ai's belongs to R. AI is for all I Okay, for all I. So this is polynomial function. Basically, here we are seeing that here we have term of x raised to power n, x raised to power n minus 1, x raised to power n minus 2, like this, right? In the decreasing order, in increasing order, doesn't matter, but we have a term like this, and all the coefficient of x r belongs to this r. So this is a polynomial function. If you take n is equals to 2, then you will get quadratic function. Okay. Okay, this is just a definition. Similarly, you will have linear function. In the linear function is what? I am taking all the thing together. Okay, what is linear function? In the linear function case, your n should be equal to 1. Okay, then you will have a function like this: fx is equals to a1x plus a0. Okay, then another function is known as cubic function. Cubic function is what basically? Here you will take n is equals to 3. So this is your main function, general function, polynomial function. And according to this polynomial function, what you will have? You will have, if you will take n is equals to 1, you will get, if you will have n is equals to 0, if n is equals to 0, you will get constant function like fx is equals to k type. Okay, this is a constant function. If you will take n is equals to 1, you will get linear function like this, a1x plus a0. If you will take n is equals to 2, n is equals to 2, you will get quadratic function. Then if you will take n is equals to 1, you will get linear function or equation of line. Understood up to this? This is just a definition. Or for cubic function, take n is equals to 3, then you will get fx is equals to like this. a3x cube plus a2x square plus e1x plus a1. Okay. Here a3 is not equal to 0. Again, the leading coefficient. Okay. So basically here, what will be the maximum power in the polynomial? If x in the polynomial term, you will have x raised to the power 5, and this is the maximum one. This is known as degree of polynomial. Okay. Okay. So if I will ask fx is equals to x5 plus 5, what is the degree of this polynomial? So what it will be?
5.
Highest degree. What is the highest degree? 5. And the coefficient of highest degree is known as coefficient. Highest power. Okay.
Yeah. And highest power is known as degree.
Yes. And the coefficient of highest power term is known as leading coefficient. Okay. So this is very important term. Okay. Leading coefficient and degree of the polynomial. Okay. So 2 degree of polynomial is known as quadratic function. 1 degree linear function. 0 degree constant function. 3 degree cubic function. Okay. Another degree polynomial. Okay. Okay.
Yes, sir.
Yes, sir.
So in the polynomial case also, if there are some alpha belongs to R such that your f alpha is getting 0, it means that if there exists, see here x, the domain of this polynomial can be R. So if there is some R for which this whole expression is getting 0, suppose you have a polynomial x square plus 2x plus 1. Okay, now take x is equals to minus 1. What you will get? F of minus 1 is equals to 1 square minus 2 plus 1. This is becoming 0, right? Right? For x is equals to minus 1, this whole term is becoming 0. Right? Right? Say something. Hello?
Yes, sir.
Okay. Then this minus 1 is said to be zeros of function f. Okay, understood? Or here, this is for quadratic function. Any example you can take. So similarly, if alpha belongs to R alpha belongs to R such that if alpha is equals to 0, then we will say alpha is a 0 of function f or polynomial function f. Okay, so what we have seen, what is polynomial, what is degree of a polynomial, and what is zeros of the polynomial, and what is leading coefficient of a polynomial. Okay, okay, understood up to this?
Yes, sir.
Okay.
Yes.
Also, remember one thing, that always leading term of the polynomial will dominate the entire polynomial. What does it mean by dominate entire polynomial? What does it mean? It means that suppose you have a polynomial like this, minus x cube plus 3 fx is equals to. Then as you can see, if you will take x is towards infinity, what does it mean towards infinity? Because it means that I am putting x larger and larger value of x. Then as you can know, you will get larger and larger value with due to this x cube, and because of minus you will get smaller and smaller value, right? Suppose you are putting x is equals to 1000, what you will get? You will get f of 1000 is equals to minus of 1000 cube, right, plus 3, right? This is the smallest value, very small value because of this negative, right?
Yes, sir.
So because of this leading coefficient, this will always dominate. Okay, if this is negative, then as x goes to infinity, if leading coefficient is negative, then if x goes to infinity, whole function will go to minus infinity. If it is positive, then if x goes to positive, x goes to infinity, whole function will go to infinity as well. And also it based on the degree as well. Why it based on the degree? Suppose you have fx is equals to x square plus 3. Okay, this is your function. Now here if you will get x goes to infinity, also because of this leading coefficient, x square will also goes to infinity. If x square is going to infinity, whole function will go to infinity, right? Right?
Yeah.
Right? And similarly, if x goes to minus infinity, then also x square goes to plus infinity, because here of this evenness is coming, right? Because of this degree. Right? Now again, if you will, if I will give another example, x cube plus 3, then here if x goes to infinity, I know fx will go to infinity, that I know because of this x cube. But as x goes to minus infinity, here what happened? X goes to minus infinity, your fx is still going towards infinity because of this square. But here if x goes to minus infinity, your x cube will go to minus infinity, and your, in this case, your fx will go to minus infinity as well.
Yeah.
So in the, on the base of the degree, and as well as on the base of the leading coefficient, that particular term will always dominate your entire polynomial, right? Okay, this is one observation. Okay, understood up to this?
Yes.
Yes, sir.
Any doubt? Please ask. No doubt. Shall I move forward?
Yes, sir. Go on.
Okay. So let's get back to the quadratic function case. So we have quadratic function fx is equals to ax square plus bx plus c. So basically, if you will closely observe, this is looking like a parabola. Okay, this is a parabola, and because of this x, either this will look like this or this will look like this. No matter this, he will, they are there. no matter. Either this will open upwards or this will open downward because of this thing. Okay, this kind of thing happens always. Okay, there is no such parabola like this. Okay, only two types of parabola will be there. Either this will open like this or this will open like this. I don't have time, otherwise I will prove how this kind of thing happen. But for instance, for now, as of now, you just remember those things. For the quadratic function case, there are only two types of parabola, which is opening downwards or upwards. Okay. Okay. Either the for the quadratic function case, either the parabola will open downwards or the parabola will open upwards. There are only two cases. Why the two cases are happening, I cannot tell as of now, because that is not important for you. This is important, that's why I'm saying. Okay, if I will get some time. Okay, let's see. Suppose you have x square plus 2x plus 1. I am showing it as by example only. So this is y is equals to this. What you can write it as? X plus 1 whole square, right? So how this parabola will look like? There is only one possibility, right? This parabola will, what is it? Vertex? Minus 1, 0, right? Right? Have you know the concept of parabola, first of all?
Yes, sir. -1, 0.
Any other person apart from that?
In short, sir, you can recap.
Okay, vertex, it means that this edge, this corner point, the lowest point. Okay, there, since this is lying in the Cartesian plane, so there will be some point AB, right? So this is my vertex. So from here you can see -1, and here you can write it as 0. So 0, 0, -1 and 0 is the vertex of this parabola. So -1 and 0, this will lie here. Now, what will, if I will put x is equals to 0, what it will be? Y is equals to 1 here, and there is no y-intercept. But if I will put y is equals to 0, what I will get? I will get -1 only. So I will get like this. Okay, so as you can see, this is opening upwards. Similarly, if I will put minus sign here, whole minus here, so I will get another parabola which is opening downward. There are only two possibilities: either this will open upwards or this will open downwards. So when it will open upward, when it will open downward, that I will explain. So see, as I have already told, the leading coefficient will dominate, the leading term will dominate the entire parabola. So similar thing. If a is greater than 0. Now, if a is greater than 0, how will you look like this, your parabola? This is your parabola, x square plus bx plus c, right? If this term is positive, it means that as x goes towards infinity, your fx is also goes towards infinity, right? Right? If a is positive, or also x goes towards minus infinity as well because of this square. So fx will go, in both of the case, fx will go towards infinity, right? Say something.
Yes, sir.
Anything, please let me know. Now, then only I will say.
Sir, this parabola, the vertex point you will get by taking either y as 0 or x as 0.
Y is 0 or x is 0. How?
So in the above case,
Here the vertex will be 0, 0 minus 1. I will let you know now how will you find the vertex from this function as well. I'm not going with the parabola case, but here I will say, let you know how will you find the vertex. Just wait a couple of minutes.
Okay.
I will give you direct formula. Okay. Okay. Suppose you have an equation of parabola somewhere here. So firstly, you have to like transform it as like y minus a is equals to x minus a whole square, or other way around, x minus b whole square is equals x minus b is equals to y minus a whole square. Then you will take it as equal to 0. Then your A and B and A will become your vertex. Okay, this kind of thing happens if you have something like y square plus ax. So this is a long thing. We don't need to do this kind of thing here. These are long thing which are in the coordinate geometry. We don't need right now. So what is my motivation from here? Here I am saying no matter what is the sign of x, it depends where the function will go. It depends on the a, right? So if a will be greater than 0, it means that for all case, all of the x is rather than irrespective of where the x is going. Like if x is going minus infinity or x is going plus infinity, your fx will go towards infinity only, right? It means that the first case will happen here both in both cases this fx is going towards minus infinity. But what I need x is going towards infinity, right? So it means what we need. So in this case the parabola fx will open upwards, right? Upwards it is opening. And the minimum, in this case what we will get the minimum value. Minimum value will be at x equals to minus b by 2a, and vertex of the parabola will be minus b by 2a and f of minus b by 2a. Okay, this will be the vertex. Now understood? Understood?
The home white beard was remarkable going around upstairs.
Hello?
Yes, sir.
Understood, right? Similarly, if a is less than 0, then what will happen? F will open downwards, and now since it is opening downwards, it means that here you will get maximum value. Maximum value, it means this will be the maximum value. All the value will be less than or equal to this value. Maximum value at same thing, x is equals to minus b by 2, and vertex will be the same, minus b by 2a and f of minus b by 2. I hope you will understand up to this. Any doubt, please ask. Any doubt, please ask.
No, sir.
Let me know. No, right?
So how we got this minus b by 2a? It's a formula there.
It's right now for you. It's just a formula. I will have some time. I will explain how we are getting this. Okay. We have some manipulation for doing this kind of thing, but we don't have that much of time, so that is why we are not going with that. Okay. Now let's move towards roots. If alpha and beta are the roots, see, I am not going with the discriminant thing, right? The discriminant will be given by b square minus 4ac, and if d is greater than 0, what will happen? D is equals to 0. What happen? D is less than 0. This is a like basic things, right? I don't need to include this kind of thing, right?
No need, sir.
No need, right? This is just a +2 material or class 10th material if you have learned parabola thing. So this is just basic things. So I am not going with that. I'm just going with the man things. Okay. So if alpha and beta are the roots, then alpha plus beta is what? For the function fx is equals to ax square plus bx plus c what it will be? It will be
minus b by a.
minus b by a, and alpha into beta will be what? C by a.
C by a.
This is the and also this fx can be written as a times x minus alpha y minus beta. Okay, this whole thing can be written as like this. Okay, so if you will open this, so from here, now let's open this. What you will get here? X square, sorry, here x will be there. X square minus alpha plus beta x plus alpha into beta. You will get this, okay? Just open this. So what you will get? Ax square minus a times alpha plus beta x plus a into alpha into beta. Now, if you will equate both things, ax square plus bx plus c, just equate the things, what you will get? Minus a into alpha plus beta is equals to b. So from here, what you will get? Alpha plus beta is equals to minus b by a. Same thing. So how you are getting this? Understood? Okay. Hello. Hello.
Hello.
Understood? Okay. Okay. So this is the thing from the parabola case, uh, or quadratic equation case, and somehow we have understood we have explained the concept of the some portion of the polynomial thing as well, and what to say. Okay, some nature of function we have to see. Though I am saying that this session is going very fast. If you have some doubts and some specific topic, please let me know. Okay. Multiplicity. What is multiplicity basically? Any idea? Multiplicity of root of polynomial equation. Okay, basically what is roots? Root is basically if you have a equation, roots is nothing but it's a zero of a function. Okay, so zero of a function is what? Solution of this, right? So zero of a function is just a solution of this equation. So the solution of the equation is known as roots of the equation. So roots and zeros, they are not different. They are just same basically. Okay, they are not different. So multiplicity of roots of the polynomial. So what is this basically? So if you have a polynomial, suppose fx is equals to x square plus 2x plus 1. This is a 2-degree polynomial. Now, if I will if I will say what is the root of this polynomial, so what you will say, sir, minus 1 is a root of this polynomial, right? Right?
That's
Or
right.
you will say minus one is a zero of this polynomial. Now, I will ask, is there any zero of this? No, because you will say, sir, if I want to equate it as zero, so what you will get? This is basically what? X plus 1 whole square. So what you will say here, 1 is appearing 2 times as a root, right? 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 You will say minus
Yes,
1
sir.
minus 1. They are this is repeating 2 times. So the multiplicity of this root is what? 2. If some root, say alpha, is repeating k times, then the multiplicity of alpha is k. Okay, we have to see how many times it's repeating. If it is repeating 1 time, so multiplicity of root k is 1. 2 times 2. Okay, so this k will be always less than or equal to the degree of the polynomial. Why? Because the polynomial can have at most n root. Okay? Understood? Any doubt,
Yes,
please
sir.
ask. Any others? If you have some doubt, I will give you 1 minute. You just let me know. Okay?
Sir, one doubt. How are we saying -1 is appearing two times?
Because of this square, I can write it as x plus 1. X plus 1 is equal to 0. So here what you will get, x is equals to -1 or x is equals to -1. For this and this, you are getting -1 two times, right? Because of this square. If you will
It
have
was
some x1 plus 1, x plus 3 is equals to 0. So here only 1 have only one multiplicity, 3 has only one multiplicity. If here x plus 3 raised to the power q is there, it means that 3 is appearing 3 times. So there will be 3 multiplicity of this 3.
okay. Okay.
Got the idea?
Yes.
How many times roots are repeating basically? That you have to see. If it is repeating k times, so k will be the multiplicity. Repeating 2 times, 2 will be the multiplicity. What is the lowest multiplicity of root? 1, right? At least
Yes.
one time it has to be there. Okay. So any polynomial function, if there will be alpha 1, alpha 2, alpha k are the roots. Okay, not go with this. Okay, this is the last thing that I need to cover. So if you have a polynomial function fx like this, I can write it as like this, right? 3, 1, then x square plus into x minus 1, x minus 2 whole raised to the power 4. Now I need to see the behavior on the x-axis of this graph. How will I see? So firstly, if I will see this polynomial, I can easily see what are the roots, right? According to this polynomial, I can easily see the roots of this polynomial, right? What it will be? -1, then -3, then x
Zero.
minus 0 whole square 0, then
1, 2.
1, then 2. Now, see, because there is positive things here in the multiplication of this. Okay, if you have a polynomial like this, something, or if you will break this polynomial into this, so you will get some coefficient, right? Here you will get some coefficient. Just see whether that coefficient is positive or negative. If this is positive, then go with this direction. If it is negative, then go with this direction. Okay, now our case, this is what? Positive, so I will go with this direction. Now since at 2 it is the function is getting 0, then it will touch to the x-axis. Getting 0, it means what? Cutting to the x-axis or not, that we have to see, right? So at 0 it is cutting to 0. Now just see the multiplicity of the very first two. Very first, here rightmost 0 or rightmost what? Root. It's, if it is even, then it will move in that direction only. If it is odd, then it will cross the x-axis. Okay, what I am saying, if the multiplicity of the rightmost, we will go by this direction. Now because of this positive, we are coming to the positive side. Now here what we have seen, that the multiplicity of this term or the rightmost root is 4. 4 is even number, so we will go this way. Now if the possibility is that if this will be odd, then we will cross the axis and then we will go this direction. But here we have even multiplicity, so we will go this way. Now because of this -1, this will again go, again we will turn and go with 1. Now let's check What is the multiplicity of this one? Please let me know what is the multiplicity of this one.
1.
1, right? It's odd. So what will happen?
Go down.
It will cross the axis. Now this will move like this. Now let's move toward 0. What is the multiplicity of 0? X minus 0 I can write here. It's 2, right? Right?
Yeah. Yeah.
So it's even. So it will again turn back. Now again it will go towards minus 3. What is the multiplicity of minus 3? Here. Again 1. So it will cross the axis. Then here, because of this 2. So understood? So some here, this kind of behavior, this kind of graph will the function make. Okay, if this is a polynomial function, the behavior of the graph of the function will look like this. So why we are doing this kind of thing? Now if they will say where the function is increasing means the values increasing order is in the increasing order. It means if x1 is greater than or equal to x2, then for that fx1 is greater than or equal to fx2 or not. This is increasing. Here the slope is negative. You will say there will be some downside kind of thing. There will be some, you have to climb. If you want to walk in this, you have to climb, right? You have to work hard. This kind of thing is happening. So where this kind of thing happening, this kind of thing happening, this will be easy if you will make a graph. Easy to see, right? So they can ask that kind of thing, where the function will increase, where the function will decrease. Don't worry, I will explain what is increasingness and decreasingness in the next session. But still, if you want to see where the function is increasing, where the function is decreasing, it will be easy to see if you know the roots and their multiplicity. So you can make a graph, actual graph of the function. Okay. And if you know the graph of the function, many things will be you can see many things. Okay. You can do many things. I will again explain how to calculate 1 if you know the graph. Okay. Up to this, any doubt, please ask. Or I will close the session.
At 0, shouldn't it go up? At 0.
Because here what x square is written, right?
Yeah.
This is x square. So x square is what basically? X minus 0 whole square, right? Yeah. So what is the multiplicity of 0? It's 2.
2.
Which is even. Yeah. Even it means that it will go down.
Even should go.
It will go by that direction only. It will not going to cross. If you have even multiplicity, it will turn back. It will not going to cross the x-axis. Okay. If you have odd multiplicity, it always cross the axis. Okay. 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 See something. Any doubt?
So why is the graph from the right side, it's starting from the positive side? Is it because the A
because of the sign? See, if you get negative sign here, see if you have a polynomial function like this, if you have a polynomial function like this, there is it like this, you can break it as its root form, right? Some x minus alpha 1 raised to the power k1, some x minus alpha 2 raised to the power k2, like this. You can break always. And here there will be some a. This because of this a, and there will be some coefficient will be there always. Okay, so you have to see whether this coefficient is positive or negative. If this is positive, it means that this will become positive. If this will become positive, so because of this positiveness, this term will always dominate. So if you will take x goes towards infinity, no matter this is odd or even, this whole term will go towards infinity. If the leading term is going towards infinity, this whole term has to be go towards infinity, or this function has to be go towards infinity, right? If this an is negative, then as x going towards infinity, this has to be going towards minus infinity. So that is why we have done here. Here, in this case, this is positive. It means that if x go towards infinity, this whole term is going towards infinity. That is why I am taking it as from the positive axis. If this will be negative, then I will take it as negative axis.
Okay, sir.
Okay, then I will do the same thing.
Sure, sir.
Understood?
Yes, sir.
Any doubt apart from this? Okay. Okay then. Good night, guys. Short hint on question 1 from mock paper. From question 1, question 1, question 1, question 1. This one, what it is saying? Let the curve represents the 3-degree polynomial fx, gx, and hx meet at point A, B. Okay. Let's curve represented by 3-degree polynomial fx, gx, and hx. So you don't have fx right now. Okay. So basically, f is meeting at A and B. So you have given that gx and hx2 function, and you have the value of f2, because you can easily calculate g2 here, right? G2 you can easily calculate. So you have the value of f2, and also you have the value of g7, f7. Now you have to find the value of f10. So how will you find the value of f10? Okay. The curve represented by the 3-degree polynomial fx, gx, and hx meet at points A and B. Is there any curve here? No. So you can calculate f2, and then you can calculate f7. Okay. You know the f2. So since it's a 3-degree polynomial, you will get 4 unknowns. Okay, I will let you know tomorrow. Okay. My mind is going stuck. Basically, what you have to do in this question. So here you will find the f2 value, and you will find the f7 value. Okay. Then I have cancelled. See. So you have something. You can find G2, right? You can find H2 as H7 as well. So from here, just find F2 and H7. Sorry, F7. Now consider, since f is a 3-degree polynomial, so consider fx as ax cube plus bx plus bx square plus cx plus d. Okay, now put the x is equals to 2, put the value, you will get one constant. Put the f x is equals to 7, you will get another constant. Okay, so from here you will get one equation. If you will put x equals 7, another equation. Now what is the another hint? Another hint is saying f and g is meeting at A, up at a point A, and f and h are also meeting at a point B. So consider f minus g as a function. Okay, so if it is meeting at A, then it will be 0 at f minus g, right? Meeting it means what? f is equals to g at that particular point. So just put that point, arbitrary point, and then try to solve that particular thing. From there you will get one another, and for b also calculate with h, same thing will happen. F minus h is equals to 0. From here you will get another equation. So you will have 4 equation with 4 unknowns. Find the value of a, b, and c, and then find the value of this. This is one way to doing this question. Another way I will think, I think you don't need to do this kind of thing. There will be some short tricks for finding this question that I am not getting right now. The curves represented by the 3-degree polynomial fx, gx, and hx meet at points. Okay, all the polynomials are meeting at one point. Okay, okay. Okay, one moment. That I. Can you tell me the polynomial? Okay, so what is this? What is saying it is f, g, and h. Both all the three polynomials are meeting at one point. So g and h are meeting at one point. So what you will do? Just point the intersection point of these two polynomials. If there will be only unique intersection point, then f also be satisfied that point, because this if the f and g h, f, g, and h are meeting at only one point. They are not only one point, they are meeting at least one point. Okay, sorry, they are saying at meeting at 2 points, right? They are meeting at 2 points a and b. So there will be two intersection points with f, g, and h. What does it mean? It means that if this is a graph of f, this will be the graph of g, then h will be also meet with this point, no matter what will be the further thing, but there will be two common intersection point. Okay, now just find for g and h. You will get two distinct point. How you will get? Here x cube minus 9x square plus 20x is there. So x cube minus 9x plus 20x, equate both the equation, what we will get? X cube
x cube minus 7x square plus 10x
plus 10x. This x cube will cancel out, square is there. So what you will get? 9x square, 7x square. So here you will get 2x square, and if you will put here to here, you will get minus times 10x equals to 0. What you will get? X square minus 5 is equals to 5x is equals to 0. Then x minus 5 is equals to 0. From here you will get x is equals to 0 and x is equals to 5. So what you will get? You have the things that f0, g0, and h0 are equal, as well as f5, g5, and h5 are equal to each other. Consider f as like this: ax cube plus bx plus c plus d. If all the things are 0, cx, so f0 is equals to 0. What is g0 here? This is your gx. G0 is 0. So what you will get? 0, 0, 0. So you will get d is equals to 0. Now here you have another function, ax square plus bx plus c. Bx square plus cx. Now another thing, f5 is equals to what? G5, as well as it is equal to h5. So no need to do this. Here also you can do f5. For that, what you will say, when cube is there, right? 125a plus 25b plus 5c is equals to g5, whatever it is, something. Now This is one equation that you have. Now from here you will get two more equation. You have three unknowns with three equation. Now you can solve. Okay, find the value of ABC and put the value 10. You will get your answer. Understood? Hello?
Yes, sir.
Yes.
Got the approach.
Okay. Okay, good night guys.
Good night, sir.
Thank you, sir. Good night.
Good night, sir. Thank you, sir.
Sir, can we
All
get the recorded session?
I think this will be streamed on the YouTube as well. This is streaming most probably. Let's take a check. I have recorded this session. I will say to Vishal sir, they will give you the recorded one. Okay.
Okay, sir. A short note, please. Short note also, please. Yeah.
Okay. Good night.
Good night,
Okay.
sir.
Good night, sir.